Oh, wait, what is happening here? I think we're good. Hello, hello. I just noticed that my camera's a bit skew. 1 second. Oh, whoa. Okay, we're good. Hello, hello. How's everybody doing? Welcome, welcome. If you haven't seen my face before, this is me. Yeah, how you guys doing? Sup, Oleg? Legend? No face, no name? Oh my, kidney stones. I hear stones are precious. Great. Emir, Marcos, Ali, Miag, Daniel. Hey, Daniel, welcome back. Hope you guys are all doing well. Um, yeah, nice to meet you too. Please increase mic volume a bit. Does everyone else feel the same way before I increase it? Is it okay for me to increase it a bit, yeah? Going to push it up a little. Just tell me if that's a bit much. So I pushed it up just a bit. Like the desktop wallpaper. Thanks. Cool. Yeah, I got asked a question about this the other day. It's wallpaper engine with rain meter. So it's pretty nice. You can go ahead, mess around with those things. It's kind of fun. You can do some cool stuff. A few changes since Saturday. Some of you were here on Saturday for the test stream. Firstly, my light is now up there, which is great. Before it was down here, someone said it looked like a campfire. So yeah, it's up there now. Found a tripod. That's cool. There's also 1080p. Yeah, we're now in 1080p, so that's nice. Not sure what else I changed. I think that might be it. Oh, and I have a bell because my brother and I had a discussion, and he said, like, to keep the stream running smoothly, we're going to need a way for me to not get distracted because I tend to get distracted and go on tangents. So he's got a bell, and he's going to ring the bell if I get distracted. So there's that. But yeah, so let's go. Let's go for this. If you're just tuning in, not sure what this is about, we're going to be recreating an effect from Loki. So that also means spoilers. I actually should probably put that up. So let me do that quickly. I'll add a little spoiler thing over here for everyone who's going to be joining. Let's just put this up. Loki, spoilers ahead. If you have not watched Loki, you've got like 30 seconds to vacate the premises. Okay, so let me just move up. I noticed I am very off center. Cool. So let's take a look at some reference material before we get into this. So I'm just going to bring up YouTube. I'm going to go for Loki Prune effect. And let's take a look at what there is over here. That's me. That's not the one I need to check. Let's see. Loki TVA Prune effect. After Effects, After Effects. That one, maybe not. Let's see. Is there any good reference?
Instead of just watching, start investing and earn.
I should probably not have ads for this. Okay, so we're using this right here. So we're taking a quick look at it. You can see this effect over here, right? The breakup effect. You can see there's like multiple parts to this, which makes it kind of cool. There is this leading edge effect, which is like a dissolve or a kind of disintegration. And then there's this interior volume where it's like rainbow colors. Looks kind of like a cosmic cloud type thing, which is pretty cool. And then there's the sparks that fly out. But the sparks, there's a lot of variation in the way that they move. There's kind of like slow moving ones, and then the bigger sort of hero sparks. But like, that's basically three effects. So you put those three together and you end up with the Loki Prune effect. And so, yeah. Of every preseason, it must be this. Lol. Yeah, right. I chose a pretty rough one. But the idea is just those three effects. So I'm going to start with the main effect. So I have my file up just in case I get stuck. One over here, fresh file, starting from scratch. Just going to go ahead, Let's drop a geonode. And I'm just going to start with doing the disintegration. So I'm going to call this disintegration. And we can start in here. So I'm just going to start with a grid because I want to show you something. I'm going to show you guys something kind of cool. This is a super secret jutsu. So I'm going to show you like a pretty interesting technique. The idea with this technique is to minimize the amount of geometry you have. So, you know, you have that disintegration. It's that leading edge effect. The issue with doing an effect like that is that you could do it with geometry where you actually remove geometry, but then you need something really high res. So like, for example, if you were using this grid and you were doing a disintegration, you would remove one block at a time and you would see that. You would see like blocks being removed, and that's not very cool. So a better way to do it is by doing it in a texture-based way. So I'm just going to show you why that is a better way to do it. So we have a grid, right? And I'm going to open Photoshop because I just want to explain something here quickly. Where is my pen? Right, pen. So you guys probably know you have X, Y, and Z. So X, Y, and Z. And this makes up, you know, your three axes in 3D. So if you have like a cube or something, it fits into those three sort of X, Y, Z, right? Your horizontal, your vertical, and depth. So in a 2D image, right? So let's just have a random 2D image over here, some mountains, whatever. You have X and Y, right? You have left and right. Now, something interesting happens when you try and convert from 3D to 2D. And this is where UVs come in. Now, a lot of you are probably familiar with the term UVs. Maybe some of you know how to work with UVs. But basically, UV is just used because X, Y, and Z is already used by 3D space. So UV is just like 2D space. So UV also runs the same as XY, right? So it also runs in a 2D sort of plane. And it's made up of like a grid. Now, why is that useful? The thing is, if you have a grid, so let's actually just do this with like a piece of geometry. So say you have a piece of geometry, just like this, and it's a cube. Or not a cube, like a grid. What we have in Houdini, like right now, that's what I'm talking about. And so we know that it would be made up of like 4 points, right? So you have a point up there, over there, over there, and over there. Now, generally, the issue with doing like a disintegration effect is you don't really have any information over here. However, if you take this and you apply UVs to this grid, right, then you can have a UV space over here where these points still kind of correspond, right? So like you'll still have a point corresponding to each of these points over here. But now, because this is in UV space, it actually gets a lot more information. UVs run from like 0 to 1. So it'll be like 0, 1, 1. And any position now on this grid you can find. So it's like giving you more information to work with, right? So instead of just having this grid where you only have 4 points of like reference to work with, you can have this UV space where you have pretty much like infinite space to work with. You can put something anywhere in UV space and it'll sort of like create an image on the grid. Okay, so let's go back into Houdini so I can actually kind of show you what all that means. So we have the grid, right? And we do like a UV project. So UV project's the easiest way to just give basic UVs. So I'm going to initialize the best plane. You won't see anything unless you drop a UV quick shade. And that's just like for visualization purposes. And now you can see we have a UV grid. It might be upside down, but yeah, it's basically working. I think it is upside down. So you can rotate it by going to the transformation and just rotating -90. And yeah, so now A2 is facing up. That's right. Before it was like the letters were upside down. So that's cool. You can also go to your UV viewport. So if you go perspective, set view, you can go UV viewport. These are the UVs. And this thing that you're seeing over here is actually your grid. Like this area with this grid is your grid geometry. It's now sort of in UV space. So it's been flattened to 2D. This is where you can start doing like texture stuff. So this is where the super secret Cup no Jutsu comes in. So I'm going to go back to perspective and remove the quick shade. So now let's say we make a scatter, right? So I'm going to take the same grid and just like scatter a few points. So like 3 points, maybe 5. We'll do 5 points. And we're going to add an attribute because we want to actually track this attribute. Also, the scatter, sorry, it needs to be after your UV project. So the idea is for your scatter points to get the UVs of that grid. So now, like that point over there, and maybe this is a bit difficult to see. Let me just increase their size. Point marker. No, wait, that's not the right one. Is it? No. Point size. There we go. Right. So this one, these little dots, they all hold UV information now, which is pretty cool. So if we take a look at these dots, you can see that they have UVs, and those UVs correspond to the grid's UVs. So like, if you have a point, you know, wherever, somewhere like here, it actually falls into the same spot on the UV grid as this position on this grid. What's cool about that is we can now give this like some attribute. So I'm going to give this an attribute and just call it, I don't know, like at test. We'll do test. Test is a nice attribute, right? Cool test attribute. So I'm then going to drop a null on the left side because I just want this to be easily referenceable. So this is just like grid out. Oh, another thing. The reason people put nulls and then make it capital is because when you search for something, so say you have like an object merge, if you search for something, you go to your object merge, you search at like SOP level, anything that's capitalized will go to the top. And then people often put like out or in so that they know that this is something going into a network or this is something going out of a network. So just keep that in mind. Like it's nice to add a null, capitalize it, and then you know like, okay, this is important, this is going out. I'm going to copy it over. This one can be like scatter out. And then I'm going to drop a copnet. So this is going to get maybe a little bit weird. So cop2 network. Over here, we can just call this like texture creator. Oh, and another thing, this will be on YouTube, will be saved, so you guys can watch this back if you want. You don't have to like follow along perfectly right now. You can just listen if you want. Talk in chat, whatever you want to do. So yeah, have this little texture creator. So you go inside and you're going to need a VOP-COP filter. Am I right about this? No, I think it's a VOP-COP generator. VOP-COP gen? Yeah, I think it's this. Okay. So we're going to make a little image. We're going to make it just like 1080, or let's make it 1028, 1024, that one. 1024 by 1024, right? No, so actually, Daniel, I do edit my tutorials a lot. I think these are the nerves talking, and so I'm probably going to mess up. So I'm going to slow down maybe a tad, because I don't want to like mess up and confuse anyone. So I'll take some breaths, slow down a little bit, and we'll go. Okay, so in here, right, you don't really have anything interesting. You just have a VOP-COP generator, and it's generating an image that's 1024 by 1024. If you go to your composite view, you can actually see what it is. It's just like a regular black image, nothing interesting. So if you go inside, you have these global variables on the side, and I'm going to make this like full screen so you guys can see what's going on here. You can press Control B to make a window full screen. It's kind of nice to do. So yeah, you make it full screen, and you have X and Y over here. And those are like X and Y in the image plane. So you have that image, that was just that black image, and you can now affect things. So like this is this color on this position in X. This is a different color in this position in Y. So with this, we're going to need to do a float to vector, because we need to take that X and Y and put it to a vector. So X and Y, and because it's an image, it has no Z. So you just have X and Y. And let me just keep this up on the side here. I should definitely have this up on the side, just in case. Yeah, so then you're going to do a PC open. So a point cloud open is interesting in that it fetches points and creates a cloud. So any sort of like attributes can be shared in that cloud. You can think of it like you're putting a pencil dot on a page, right? And if you were to smudge it, that's now like a cloud. Its variables are available around that point. So if we plug the vector into P, we're now saying, okay, this is like our position to work from. And then you can take this handle and you can fetch attributes from it. So we can actually fetch with a PC filter. So point cloud filter, you take the handle, and then you choose what you want to fetch. So we know that our points have an attribute called test, right? So we can just say fetch test, and we can apply it to R, G, and B, right? So it'll just make it like black and white. If you have the same value going to R, G, and B, then it'll just be grayscale. So next, we're going to need to define where those points are coming from. Right now it has this file thing over here, but that's not exactly what we need. So we're going to promote it. So we say promote parameter, that'll just move it up a level. The other thing, radius, search radius, I think you have to have it at like 0.5. I'm not entirely sure why. I think it's because it works with radius, so from the center out, and it doesn't detect the point if it's anything less than 0.5. So you have to start from 0.5. It's something weird like that, but it'll maybe make some sense, I hope, in a little while. So yeah, you have that. I'm going to just press Control B, minimize that, jump back up a level, and over here, you'll see that it allows us to now choose a file, right? This is where our point cloud is coming from. And so like you can go and choose something, but that's not really useful, right? Sometimes you don't want to have to cache out all of these things. So what you can do is you can select this scatter node, press Control C, right? And that copies it. But you can actually paste it in here if you just Control V. Now that doesn't work. The reason is because it's still looking for a file. You need to actually say like, look inside of Houdini for this. Don't look for like an external file. Like this isn't a hard drive. We don't have a hard drive called OBJ. So you do OP like that. And that should work. So I just need to make sure everything's working here. And I might be able to get this working in just a second. I just want to make sure I got everything right. I think the last thing, right. So remember we have those UV attributes on the points. That's actually what we want to drive the position by. So over here, under position, you say UV. And check that out, right? Those points that you have over here, scattered, are now part of a grid, like an image. So you can scatter points and generate an image and then work with this image as if it were like any other texture. You could use like a blur node on it, right? And you can blur that. You can do all sorts of things with this. And this is like the smart way to do wet maps. I know I have like a rain tutorial, and that one I do roughness and stuff for like points. That's not the best way to do it. This is like the optimal way to do texturing for like a wet map. So what you would have is a bunch of points, sort of like, so say you have like a splash, right? And it's hitting a grid. You would transfer from the splash points onto the grid an attribute like at wet or whatever. And then you take that wetness attribute into your texture and you use that to sort of drive a texture. And so, yeah, like you can increase the scatter points over here to like 10, 20, like 100. And what will eventually happen is it'll start averaging out values. That's the way it works. That's why we have this thing over here that says, inside here, it says 10 points. Like that's the number of points to sort of work with. So find the value of 10 points and like get the aggregate. So if you had to like really push this up, say like 1,000, you can see there's like very small dark areas. And it's basically just getting the aggregate. So if you had to change this to like 0.5, oh, actually, no, it doesn't work like that. Oh, no, that is the average. Okay, yeah, so it just averages like the points that are nearby. So that's cool. That's not what we really want though. So what I am going to add is a null over here, because this is kind of nice to have. And we can call this null something like out texture. Just easy reference, right? Okay, so how do we actually use this for our disintegration effect? I know that was like a long explanation, but I think it's important that that kind of thing is understood. Okay, so let's get on to like the actual stuff. But first, posture check. Oh, everyone, check your posture. Everyone thinks like Houdini is the scariest thing about VFX. It's not. The scariest thing about VFX is backache in your early 20s. So let's go ahead and start on the infection solver. That's the one. So we have these points. Let's increase it to like 10,000, right? These points are a bit chunky now, so I'm going to drop their scale. You can press D, go to geometry, point size over there. Yeah, so I want to like start an infection at a point and have it spread out. That's how that prune effect works, right? Man, which video was it? Oh, Rip Mobius. Let's go. Yeah, so as you can see, it like spreads, right? It spreads from a single point. That's just an infection solver. Like that's super simple. Lots of tutorials on infection solvers, but I'm gonna go ahead and create my own one, yeah. So a good way to start an infection is by having like an extra point on the side. So you add a point, and that adds a point at the origin, 0, 0, 0. And you can move this point around with your transform handles, right? Like you can just move it wherever you want. But I'm just going to leave it at origin. And I'm going to give it an attribute. So I'm going to give it at infect equals 1. And then I'm going to merge it in with the rest of my scatter. So now I just have like one extra point that has that infection attribute. This little error that you're getting is because all of the points on the left don't have an infect attribute. So they're all just defaulting to 0. Sometimes that's not what you want, but in this case, that's like perfect, right? You look at the geometry spreadsheet, nothing's infected except one point at origin. Cool, right? No problem there. So that means that we can now do some like Vex stuff. Sorry if you don't like Vex, I apologize. You can do this in VOPs with like point clouds and stuff, but I'm gonna do it with Vex. I like Vex. Vex is cool. So Alt-E, just gonna bring this up. I hope you guys can read the code. So before I go into this, let me just check chat, just like 2 seconds. Okay, cool. Yeah, you guys aren't saying too much. I think you guys are hopefully just listening, right? You're not all God, are you? I'm just talking to myself at this point. Yeah. Let me not spill coffee on my keyboard like an idiot. Okay, let's go. So we have that one point, right? And so we're going to say like if a point is infected, so if at infect does equal 1, then do some stuff. So we're just going to say find like neighbors to this point. So we say int npt s, near points, neighbors, whatever you want to call it. You put the 2 square brackets because we're making an array. That's fetching a bunch of points, putting it into an array. Equals. And then you use the near points function, and it takes a couple of arguments. If you want to see the arguments, you can press space and then backspace, and it brings up all of this stuff, right? It's pretty nice to have. So we need a geometry. So that's a geometry input. We only have one input here. That's 0. So vector pt is just your position in space, and then the maximum distance from that point that you want to find points, and then optionally you can have like the maximum number of points. And so let's start with geometry. Geometry stream 0. And then you want to do the position. So that's v at p. And from there you need an area. Yeah, around. So 0.5. Actually, we should make attributes for that, or variables rather. So let's create some variables up here. We'll have one called float radius. That we can just make equal to a channel float. So the float, like, it allows you to just have it as a separate parameter. So float, we can just call that radius. And then int points. So we can just choose the number of points that we want. Equals channel integer, so chi instead of f, points. So now we're choosing how many points we want. So then we just say radius in here, comma points. And that's cool. It should fetch some points for us. Then for each of those points, we're going to need to do something, right? For each, and then we can open brackets. So like in here, what we need is int pt. And then you do a semicolon. It's a bit of a weird syntax. I know, it's like, that's a bit odd seeing a semicolon over there. But int pt, and then the array that you want to check. So what you're doing with this is it'll say for each element that is found inside of npts, put it into pt. Then that means that inside of here we can work with pt. So we can work with like each element iteratively. Maybe I should just like draw that out just in case anyone doesn't get that. So it's like if you have an array, so this array is full of points, right? And maybe that's like point 1, 2, 3, 4, 5, 6. What PT does, so in your for each, you'll say like int PT, it'll fetch one of these and put it into PT. And then you can work with it. You can say like move point 1 this way, and then like point 1 will move that way. And then it'll do the next one. So it'll move on to number 2, and then it'll do some stuff for number 2 and move on to 3. So basically it's just allowing you to take your array and do things like one at a time, 1 point at a time, which is nice. So now what do we want to do per point? Well, we actually want to give the points nearby an infect attribute. So we say set point attrib, 0. So that's the geometry stream, the attribute that you want to affect. So infect. And I believe it's the value you want to give it. I don't want to get that wrong. It might be the other way around. The value you want to give it int point num. Oh, then the value. Okay, so the point number. So that will be PT. And then a value to give it. So like 1. And then you can just say set. So what you're doing is you're saying, okay, find the infect attribute for point PT. So it's fetching the point number from the near points that it's found. And then it's saying, okay, for point PT, set its infect value to 1. This little set thing at the end is, there's like set, add, there's like a bunch of modifiers, but like set's generally the one you'll use. So apply, accept. And if we drop just a color node, I mean, you can also do this with like a visualizer, but I like color nodes. I don't know why. They're kind of just fun to play with. So then you put like infect over here, and everything's infected, right? Because over here, radius. So a radius and a number of points, and everything's still infected. What did I do wrong? At infect. Okay, so everything's getting an infect attribute. I need to just check why. So if infect equals, guys. Yeah, it's actually kind of funny. So I have a thing that I say very often when I'm working in Houdini and like working on VFX stuff. I always say, it's always something. Something's always going wrong, man. It's always something. And my brother and my mom actually bought me a hoodie for my birthday that actually says, wait, I need to see if you guys can see this. It says always something. This way, always up, oh, that way, always something, and then 24, because that's my age. But man, it's always something. I swear, it's always something. Bro, I left out an equal sign. That's 1 equals. Used to be 2. This is checking. Like, if it's true, this one is assigning. So it's actually saying at infect equals 1. That's not what we want. We want to check, is it equal to 1? Slight difference, big change, right? So now it's infecting some points. You can change the radius and the number of points that you want to infect, and like that works. So that's cool, right? But kind of pointless. What we actually want is to put that into a solver. So we drop a solver, and this is where it gets kind of cool. So you take this, right? I'll just Control X to cut it, and inside of here, just Control V to paste it. You take previous frame, you plug it into first input. Now this is kind of cool. Every frame, it'll fetch the last frame and run this code again. So like first frame, you'll have 1 point infected. It'll do all of this, and then like maybe 10 points will be infected. Then it'll run it again, and then it finds like, oh cool, there's 10 points. Let's run it again. Yeah, and so if you try that out, and I just noticed I also spelled this wrong, Disintegration. Oh man, creation. Yeah, so now it's in a solver. So let's try the solver. I'm just going to set real-time toggle on, and then play it. And look, infection solver, right? Simple. It's just like straight up. And you can change settings on here so that it behaves differently. Like you can change the number of points that it infects each time. So like only 5 points will make a completely different like speed to it. And if you change it to something like 3, you actually get some pretty cool things, like it now follows paths. And like you can do cool effects with that alone. So like keep that in mind if you want. Like that's a pretty cool thing, working with infection solvers. There's lots of cool things you can do with this actually. You can even do stuff like if x is greater than the current point's x value. So it'll only move to the right or something. But yeah, this is like the ground, like the base of really cool infection stuff. So yeah, now we have that. And we have an attribute called infect, and it spreads all over. I'm just going to switch this back to like 5. And so that's nice. But I do want to add some stuff. So in here, I'm going to add a bit of code just to kind of spruce this up. Because the idea is you have this leading edge, but only the edge needs to be bright, right? So we actually want like a really hectic edge, and then it fades off over time. To do that, we're going to need another attribute. So we can make one called like, I don't know, let's call it, what do we call it, guys? Intensity. Let's call it intensity. Intensity, comma, pt, comma 1, comma, set. And we actually only wanted to set intensity to 1 once, right? It mustn't always be 1, because we wanted to hit 1 and then fade off. So what we can do is we can say, like, so we have infect. Let's think about how we want to do this. So what is the best way to do that? We have infect. Just thinking. I don't want to give you guys some like bad stuff. If intensity is less than a certain Oh wait, okay. This is easy. If what we'll do is we'll fetch the value from like this particular point. So we find a near point and we fetch its infect value. If it's already 1, right, then don't make intensity 1. But if that point is 0, then we should infect it and make its intensity 1. Maybe that'll make a bit more sense like soon. But we'll have something called float like infected. So we want to know, is it already infected? And that will be equal to point. So point is a way to get an attribute from a particular point. So we say 0, comma pt, or firstly what we want to get. So we want to get infect. And then we want to get the we want to get it from pt. So we're getting the infect value from the nearby neighbor point. And then after that, we can say if that infected value is less than 1, then give us high intensity over here. And then after all of this, so like right at the end, you can go like, where's the best place to do it? Maybe at the top even. You can do at intensity. So that will be the new attribute that we have. And we can make it times equal channel float. And this channel float we will make for like conservation. So how much intensity is saved to the next frame. So we can call that conservation. And let's apply, accept. And over here, we'll say like conserve most of it. So we create our spare parameters, conserve most of the intensity. Go up a level. Let's just reset. And we let that run. So we have the one attribute that we're checking, and that's infect. And then we should have another attribute called intensity. Right, cool. Okay, it's working. So as you can see, it like fades off over time. Because what we're doing is we're checking if a point's infected, then like don't make its intensity high. But if it's not yet infected, but about to be infected, give it intensity. So only the leading edge is getting intensity, right? It doesn't repeat on these inside points. And then we have conservation. So we're basically just saying, multiply it by this value. And because conservation is less than 1, each time this code runs, intensity is dropping very slightly. And that's cool, because then we can also do like a little bit of extra code where we just say if at intensity is less than like 0.01. Let's do like say if it's really, really low, just like set it to 0. It's fine. And we also want it to be that happens if infect is also greater than 0. So if infect's also greater than 0, and that's at infect. So we have two conditions there. If intensity is very low and the point is infected, then set the intensity, so at intensity, to 0. And I'm going to add an attribute here. I'm going to call it at cull. And I'm going to make it equal to 1. Basically, I'm just going to remove the point if it's already done its job, right? So now what we have is this. As you can see, like those center values are returning back to 0. And maybe there's a better way to visualize this. Now I'll just show you with like infrared. So now you can see like when it's returning to purple, it's going back to 0. So that's cool, right? You can even check cull. You can see that those center points are the ones that we can remove. They've done their job. Like the leading edge is already past them. We don't need it. So like we can remove those. So we can just add like an attribute wrangle over here where we say, oh, I should save. Ooh, yo, I'm playing games with my life here. If anything happened to the stream, man, I've got her off. Okay. Yeah, so we can say if at cull greater than 0, then just remove this point. So we say remove point. And you need to just tell it like what to remove. So just say 0, comma, at ptnum. So remove the current point from the first input. That removes those points. So like if we don't need the points anymore, get rid of them. Cool, simple, right? So yeah, I'm gonna take a second to breathe because I haven't done that in a while. Take a sip of coffee, read some chat. You guys have anything to say? Also, for some reason, there were more people for the test stream. That's kind of odd. And thanks. No face, no name. Don't forget to save. Thank you. I appreciate that. That was yeah, useful advice. Okay, let's check out what you guys are saying. You need to put equals equals instead of equal. Yeah. It's a rough one, man. Okay. Your brain is a supercomputer. Thank you. But honestly, like it's just years of doing the same thing, man. It's I feel like most people do eventually get there. And like for me, I think I'm fortunate to be at a good place in my Houdini knowledge where I can sort of just free flow. There are definitely things that I get stuck on a lot. It's just on like bigger projects. Where did you get the name Nine Between from? Oh, that's a pretty fun one. So my brother and I started Nine Between, right? We started the company. And he's 9 years older than me. So we're like, what can we call this? Ah, there's 9 years between us. Let's call it Nine Between. That's it, really. So yeah. Hard work, yeah, man. Hard work. It's always something. Thanks for the tutorials. Cool. It's a pleasure. You know about the app data save crash thingy? What? No, I don't think so. App data save crash thingy. Not sure which one specifically. Are you currently in South Africa? Yes, I am. Johannesburg. You don't get any more information than that. Okay, cool. So I'm gonna get back to it. If you guys are cool with that, you cool? We good? We good? Do you guys have your beverages? Which software is this? It's Houdini. You can check side effects Houdini. Are you planning to do more tutorials? Yes, we are. Just busy with some like commercial work. So doing visual effects stuff on a TV series at the moment. We're busy with some other stuff. And so yeah, I thought you were like 35 to 40. Yeah. Maybe I am, man. Maybe I am. I just blessed with those genetics there. Okay, cool. I'm gonna go back into it. Let's see, where was I? Thanks for the tutorials, love from India. Thanks. I'm gonna try to say your name because I appreciate when people mention like that. Dalmordaran? A? Okay. Continue. Bring Loki back. Yeah. let's continue. So, okay. So now we have like a bunch of stuff to work with, right? We have at cull, we have at whatever, infect, at intensity. So we have the three. Intensity is like the leading edge. Cull is like the points that have done their job and we can get rid of. And then infect is like, has it been infected yet? So that's cool. Now we can actually take that attribute into the scatter node, feed it into our texture creator, and we can fetch it in here. So this PC filter, before it was fetching test, the only thing we have to change is now it just has to fetch a different attribute. So now it has to fetch intensity. So intensity, just like that. And if we take a look at our composite view, take a look at that. That's pretty sick, right? So now we have an actual texture that's being driven by our infection solver. So this can be like super high res. And you can do some awesome stuff with this. So you can apply noises to this. You can do cool stuff. So yeah, man, like that's pretty big. The next thing that we want is an opacity mask. Oh, Strider, yo, what's up, man? Hello. Nice to meet you, Stridos. Yeah, so wait, where was I? Okay, so we have the one, but I'm going to duplicate this over because we also want one for the other attribute, right? We want one over here for infect. So this is like the solid one. So now you can see like this should cut things away. But cull is actually an issue. So what we're going to do is we're going to have one scatter over here, and then I think another one over here, where we're not removing the points. So this one over here, we can have scatter, can call it like infect out. And the reason I want two, so I'm just going to have here scatter underscore infect out. The reason we have two is, hello? Oh no, not like this. Oh, okay. Yeah, so as I was saying, the reason we have two, all right, we have this one and we have this one. We're going to use this one for opacity, and I think that's just like a rendering issue. I don't think that's actually there. Or is it? Hello? You good? I don't know what that is. Okay, well, we'll fix that. Let me just take a look. I don't actually know why that's there. That shouldn't be like that. Interesting. Give me a second. Just, it's always something, guys. 5 points. Whatever is happening here is interesting. Huh. It's got a second bunch of points over there for some reason. That's weird. Infect? Vector channel, is that maybe why? Float? Yes, no, maybe? Big question mark on that one, but this one's working. Let me actually just try duplicating this over again. Just in case things got buggy for some odd reason. Let's see. Infect. Forget what I call things. Okay, yeah, great. What? No, wait, that's still not working. Oh, right. Go easy on me, guys. My first stream. Still broken? Okay, I actually don't know why that one's broken. I'll try and fix that. But the idea is you have this one for emission, you have this one for opacity. So let's actually use that like in a shader now. I'm going to be using Redshift because it's like basically real time and I can use it on the stream, so that's cool. You can use the exact same technique kind of in like Mantra, whatever renderer you're using. So yeah, I'm gonna go ahead, use Redshift, go up a level, drop a material network, just call it materials, dive inside, and I'm gonna drop a RS material. So RS material builder, I'll call this am I spelling disintegration wrong every time? Disintegration Yeah, just call it that. That's fine. So over here, we need to fetch that texture that we have, right? So we have this texture, but we kind of want to bring it in. So to bring it in, we need to fetch it. To fetch it, we can do something like this. So we drop down a texture node. In Mantra, I can't remember what this would be called. I think it is still just like texture. I'm going to plug it into diffuse color just so we can see. But the file name over here is actually going to be the name that we have inside of our cop thing over here. It's going to be this out texture. So we can press Control C, go up into here, and right over here in the file name, we'll paste. But remember, if it's actually like a path inside Houdini, you want to use OP. So OP, semicolon, or colon, and you have that, right? And that should fetch the texture. So now what we can do is set our display flag on this grid and give it the material that we just created. So we can just say material over here and choose the material that we made. So we have it in materials, disintegration. Cool. Another thing, I kind of want to set this out so it's a bit neater. Press Shift S. That gives you some nice little node connectors. I know a lot of people prefer these node connectors. That's all I'm going to do for now, really. So yeah, let's test that out. I'm going to drop a camera, and I'm going to drop a redshift light dome, just so that we have something. Maybe I'll give it an HDRI. Let's do that. Somewhere I have HDRIs. Yeah. Let's do Glurfendal. Let's go. And materials, I'm just going to drop the reflectivity on this, so it's not so shiny. And open render view. Let's see what we got. Yeah, right. So now our texture is actually appearing on our grid. So this is like the sick, really sick thing about this. It's pretty cool. Have you tried Blender? Yeah, actually like four years of Blender before Houdini. We're kind of using Blender before it was really good. Like it's really good at the moment. I still wouldn't like go back to it, but we kind of capped out. We reached a limit in Blender, and like the next step up was Houdini, and so that's what we decided to do. So yeah, move to Houdini. Don't regret it. Houdini's awesome, man. I'd like 100% recommend. So yeah, the idea that we actually have with this is Blender's a cuss word, right? Yeah, yeah. Sorry, I'm gonna need to censor the stream when we're done. So yeah, if you take this into something like your emission color, and then you actually provide emission. So over here, you just push up emission weight. You can see that that area is now glowing. The cool thing is you can also plug a ramp into this, so RS ramp, and this ramp can taper off. So we can have, say, infrared, right? And now it goes from like purple to that color. And if you also like plug that into, oh wait, we make this black over here. That's fine. Right, so now it, that gave me a fright. I couldn't see who subbed. Who was that? Josh. Thank you, Josh. Thank you for subbing. Yeah. So we have that now, right? And if we had to change the color of our diffuse, you can actually see that this is pretty nice. You have like that leading glowing edge. So we can now move on to actual cool stuff. Now that we have this, let's replace it with a flippy, and let's also figure out our opacity thing. Maybe it is working, actually. Maybe this opacity thing is working. Maybe it's fine. I don't know. We'll see. So we have out texture 1. I should probably rename this to out opacity. And I'm just going to copy this, Control C, once again, like earlier. And go into the materials, disintegration, copy over the texture sampler, paste in here, change this to OP, and now I can feed this into opacity. So opacity is over there. And it's working, but for some reason, guys, why is that there? Okay, so I'm going to need to just try and figure that out. That shouldn't be happening, but who knows, man? Weird things happen. Okay, so I just want to make sure that I'm getting everything right here. Just checking my file. Ohana. Ohana means family. Who is that now? Mikhail? Michael? Why should I say Mikhail? Michael, welcome. Thank you. Okay. So Man, I'm getting distracted now. Okay, let's see. PC filter. I'm just making sure that I got everything right here, because there is like this weird issue, and I'm not sure why it's happening. But worst comes to worst, I'll just copy this over. The other thing is we actually need to invert this, because opacity is, it's like 0 is you can't see it, 1 you can see it. So we'll just do invert over here, and that'll flip it. And we'll try and figure out that like weird gray area. I'm just going to promote some stuff. I'll promote radius over here. So promote that parameter. Let's also promote the cone. And let's give that a try. So cone angle. Let's see what happens if we change that. I'm just going to close this quick. Motion effects. No, comp view. Yeah. Okay. Let's see where this is going wrong. I wonder if it's that one extra little point. This one over here. I don't think so, but it could be. Could very well be. So what we'll do is we'll actually group it and remove it afterwards. So I'm just going to give it a group. Things are very slow now. Something wrong with this. I'll try and figure that out. So yeah, let's just do points, and we can just call this like starter. And then blast it afterwards. Blast it, man. Okay. So reset some. Let it play back. And let's test removing the starter. Remove starter. And that should be cool. Should have 1,000 points now. 10,000, that one. Yeah, so I'll rather do this over here. So let's take a look. That maybe works. Yeah. Right? I think that worked. Man. Who would have guessed? Okay, so now that works. Let's use it on a flippy. So I'm going to drop a rubber toy. And I will be using like the Loki geometry. There's probably going to be a 2-part, by the way. I don't think there's any way that I cover everything today. So yeah, I'm going to use a flippy. He already has UVs, so that's pretty nice. Can get rid of the UV project. And you can just chill there. This point over here, I'm going to need to move to like his chest area. So I can just move it over there. Like that. Right, so now we're starting the infection from this point, which is exactly what we want. So let's test that out with our solver and our color node. So we won't use color, we'll use intensity. Intensity's nice, looks nice. Just gonna make this black. And let's test that out. Yeah, right, so you can see the infection solver works perfectly. That means that it should work just as is. If we switch to our flippy, it's now called grid out. Let's just call this geo out or something. Now it should work, right? If we take a look, redshift, open render view, give it a second. Our flippy's tiny. Camera. I'm getting whispers from somebody on the... Let's save time, everyone. Okay, save and move in. I'm just gonna hide my dome light. So let's just enable background, switch that off. Don't need a background. Enable in viewport. Where's that? Yeah, switch that off as well. And so, as you can see, we now have that fairly interesting looking fade off, right? That's kind of low res because there's only a 1024 resolution image that I'm generating. But now what we're going to do is we're going to take this disintegration thing and we're going to change the colors on our ramp. So we can remove like the teal color. We'll just use like red on the low end. So like over there. We'll do like a pink or a white up towards the upper end. So right over there, and maybe a white at the highest point. And then we can just drag it around until it starts to look cool. Something like that. I'm going to drop this red a bit. Yeah, so something like that's okay. Over here, I'm also going to increase the emission weight. So I'm going to push it up to like 10. Right, so now it's pretty bright. Over here, if we go to our settings, you can actually do like post effect stuff in your Redshift render view. So you can add things like bloom. And this is actually a big part of the effect. Adding bloom, you add flare, streak, all of those things. If you don't have redshift, you can still do all of these compositing tricks, but I'll have to get to that later. When you're rendering, you want to render out passes, so you have like the emission layer and all of that, and you can just like blur things. So for now, that disintegration's fine. What we probably want is more points, so we can push that up to like 100,000. We're going to run that solver, and let's take a look. I don't think that reset, so just reset. Yeah, okay, cool. So now let's go to our texture creator. Over here, we'll increase this to 2048 by 2048. Make it nice and big, nice and chunky. 2048, 2048. Yeah, so now if you take a look, there's also something that's pretty cool. You can actually see that it's splitting it up, right? With the grid, it wasn't so obvious. But now you can see it's like using the UV map that Flippy has. Because if you check out Flippy's UVs, so like UV, whatever that is, that thing, and we go over here, you can see, right, like that's his little body, and the corresponding spots over here, just like that, right? So you can see that there's areas that correspond. So we're basically converting from positions in 3D space to the UV positions. That's like the main idea of this. Cool. So I'm going to take a quick break to look at chat, check what's going on. Just want to see how things are going. Also breathe again. It would be nice to breathe. It'll make you switch to from After Effects to Fusion. Yeah, true. Man, After Effects is a rough one. I don't know. Do you guys enjoy After Effects? Like the guys who do use it, yeah? I know how to use it, but I don't enjoy it. I'm not great at it, but like, man, I struggle with After Effects. I mean, with geometry nerds, you could do pretty much anything. Just kidding, I hate Blender. Yeah, you're Lan. That's what's up, man. Uh, see, I hate that Z-axis is up. It really throws me off. Is that in Blender? Where is Z-axis up? I can't remember. Is it Blender? Fit range 0 to 1 to 0.1 to 1 should be okay. Yeah, but I think like it wasn't supposed to be that way. Yeah, sorry, this is all like a little bit far back in chat. I'm only catching up now. Luckily, I found you. Hey, thanks, Josh. Okay. Oh, quick on Rush. What are your thoughts on 3ds Max plugins like Phoenix FD, Fume Effects, and RealFlow? They're good. They're really good, but they're not in one package. So learning them can get kind of clumsy. Like I personally don't have any experience with it, so I can't exactly talk from like a place of authority on it. But just the idea, right? You have separate packages to do separate things. In Houdini, you kind of just understand a single workflow and you can do like all of the stuff, which is kind of nice. So yeah, like I can't really talk too much on that. Thinking about modeling. Jeez. Rough. No face, no name. Pruning his ex-wife from existence. Fume effects sort of obsolete. I suppose, yeah, it could be. It's possible to create this effect without UVs. Yes. But UVs are awesome. And you're going to want to use it to texture anyways. So like for actual big projects, you're definitely going to want to have UVs. You can just do like a simple disintegration thing. Even like in the Phoenix tutorial that I had a while back, like that works with like basic disintegration. You could even do a thing where like you use the scatter node to transfer this infect attribute, wherever it is, infect, onto the main geometry and then remove all of those points, right? So you're actually cutting away from the geometry. That's an option. Where was I? What render engine do you recommend? I'm thinking about RenderMan, Arnold, Redshift. Yes. Okay, Arnold. Very realistic rendering. It looks great. Love Arnold. RenderMan, we're busy experimenting with it. Mojo's actually experimenting quite a bit with that. It seems awesome. Redshift, I love for like really quick, just like putting things out. So it's nice for tutorials, it's nice for commercial work. But if you're doing like realistic stuff, Redshift isn't the best, but you can get realistic results with Redshift. It's just not like perfect for it. Isn't Nuke crazy expensive? Nuke's expensive. What should I learn with Houdini? Can I get employed only with Houdini? Yes, you can. Houdini artists earn pretty well, especially overseas. Like South Africa, it's maybe a bit difficult to find jobs. But like if you can get a job at one of the bigger studios like DNEG or I don't know, man. Okay, I don't want to say ILM. That's really big. That's going out there. But yeah, like lots of the big studios overseas, you can get a fairly good living from that. Even freelancing, like freelancing as a, if you're a dynamics specialist. Okay, so I'm gonna give you, from what I know, crowd sim guys are very much like in demand because there's not many crowd sim guys. Flip dynamics, fair amount of people do that. Fair amount of people do destruction. There's still like very good jobs in those areas if you can get good at it. But like the crowd sim guys, they get like they get a lot of jobs, I think. I'm not certain on that, but I think they do. So I think a problem with Blender is an amount of beginners. It's hard to find advanced tutorials. The other thing is that also Blender, like, it does just cap out. It really does. Like, Houdini's meant for a pipeline, like, sort of in the industry. Blender isn't there yet. So sort of the mind frame, the sort of perspective around each one of them is very different. Like, Blender guys are like hobbyists a lot of the time. I'm not saying always. Hobbyists or small studios. And like Houdini guys, they're expecting to go into film. They're expecting to go into like movies and TV series and big commercial work. So Houdini's always going to have like higher end tutorials because it's more, it's less hobbyist, right? If you're learning Houdini, your chances are you're not learning it just for fun. You're learning it to like get a job or whatever it may be. Aim for ILM and settle for DDEG. That's a bit rough, man. Settling for DDEG is still great. But they pay like poop. India has lots of DNEG studios. They all pay like poop. How do you apply this to a fast-moving geometry? So like if your geometry is moving, what you want to do is you want to first like shift it. So it's a static frame. So you do like a time shift. You time shift to the first frame. So you just delete this. You say frame 1. And then like it will remove any sort of transformation from the stuff. Then you run your solver. So you run all of your infection stuff. And then what you do is you want to reapply the animation to these points. To do that, you might not even need to because it's working with textures. But the main thing is that time shift. And then if you want to, you deform your points with a point deform. So you take the static geometry, deforming geometry. You take your points, you take your static geometry, your deforming geometry, and it will deform your points based on the deforming geometry. That maybe sounds a bit confusing. I would like to get into it, but I'm kind of trying to keep this going. So yeah. Max for modeling. Do you think Houdini can be used for modeling? I would say yes. Can be used for modeling as efficiently as Max or Maya. Maya definitely still has like an upper hand when it comes to modeling. Like it's what it's made for, basically. So I don't think anyone's really gonna beat that. But it also depends what type of modeling. Yeah, like good for proceduralism. If you're doing things where you just want to like iterate and make variations of things, then like Houdini's awesome. Say you were doing like game development, right? If you're doing game dev and you wanted like various types, or you wanted like a bridge tool that generates a bridge depending on different like gaps, spaces, you can do that in Houdini. That's really cool. And so there's lots of stuff like that, which makes it a bit different, but you can still do like traditional modeling, definitely. It's just it takes a bit of getting used to because it's a slightly different workflow. I started modeling in Houdini. Guys, it is the best tool in the market. Yeah, it's nice. Yeah, like I don't think it's bad by any means. I don't think it's maybe a fair comparison with Maya, but like it's good. Okay, yeah, I'm getting sidetracked. Don't ring the bell, please, please. No bell, no, please. Okay, time to go. So yeah, I think the next thing that I would like to do here is kind of work on the fade off. I think that it should fade off faster, so there's like a narrower band. To do that, we can decrease the conservation. So we could do like 0.7. That will kind of kill off that effect a bit faster. So if we check intensity over here, intensity, yeah, so it's just killing it off a slight little tad bit faster. So that's nice. I just want to check how this high res one looks. So open rent view, we'll see. Yeah, so like that's looking closer to what we want. But this is cool, right? Like opacity is allowing you to sort of cut things out. And you can see that there's like a little extra point that's kind of showing through. That's just because our disintegration solver over here isn't infecting enough points. 5 is a bit low. I would say push it up to like 7. That's probably fine. Also, the disintegration is probably a bit slow. I actually want to check this out because like in Loki, it's actually a pretty quick effect. I would say it's maybe like 2 or 3 times faster than this. Let's just take a look. I think this is going slow. Yeah, like that's a pretty quick effect. So what you want to do here is increase substeps. So on a solver, substeps are just how many times am I going to do these calculations in between a frame? So if there's like 2 frames, a substep slots in right here. So it's like an extra calculation. So if you do 2 substeps, it's doing the calculations twice as much. Or not twice as much, but it's doing it an extra time in between frames. So if you do that, like it moves faster, right? And you can go even faster than that. I think I did only do like 2 times for the actual video that we released. But yeah, something like that, that gives you a pretty cool effect. So many post-processing in Redshift. Houdini devs need to get on that for Mantra or the next render engine. The thing is, like, side effects is very much focused on industry pipeline. And in the industry, your post-processing is done in things like Nuke. Oh no, spoilers. I'll be back after watching Loki. What? Oh no. What are you doing here? It even says Loki spoilers. Oh no. Oh no, bro. Not like this. Now I just feel bad. Yeah, but like I was saying, Houdini is pipeline oriented. So they don't really focus on like their renderer too much. Because most of the stuff's done in Nuke. There's like a full pipeline for it. You give it to the Nuke guy, the Compositing guy, and he does all the stuff. So yeah, this is what we got so far. So as you can see, that's like a pretty good start. What I want to do next is work on that interior sort of cosmic effect. That one's a little bit more tricky because we're working with volumes. In the actual show, I can sort of see that they used an actual pyrodynamic. There's like, okay, spoilers coming up. There's a little bit of, like, as you can see over there, like that area around there, I think that there is a sort of smoke simulation, very light. Yeah, I should actually. But yeah, so the sort of smoke effect is very subtle, but it is there. And so I'm not going to do an actual simulation because I think it's unnecessary. It's very subtle, but if you're doing this for like a movie, you'd probably want to do like extra cool stuff. So we're going to take our little flippy and we're going to do an ISO offset. So ISO offset just turns us into a volume. We're going to increase the uniform sampling divisions. We want a pretty watertight volume, right? So that's pretty nice, just like that. Then we're going to scatter again. So we're going to use a new scatter node. We're going to scatter into the volume, and we're going to scatter quite a few points. We can switch off relax iterations. This is what makes scatter slow. It basically just tries to keep points kind of equidistant, so they're evenly spaced. We don't really need that. So we can just do that, and then it's like really quick at generating lots of points. So yeah, we can do like, I don't know what that is, 200,000. That's 2 million? Okay, that's maybe pushing it. Ohana means family. Thank you for subbing. Who was that? I can't say that name. I mean, it's not like vulgar. It's Russian. Cyrillic. Cyrillic. Yeah. So we're going to take our same solver over to the side. We're going to do the same thing where we merge in that starter point. But this time we're merging it in with this volume scatter over here. We plug this in into the solver over here. And let me show you what happens now. So I'm going to jump back. This one will be slower. Do keep that in mind. This one is like significantly slower. And so, oh, let me save. So let's test this one out. Don't know why it's trying to go to frame 80. That's not where I was. Hello? You okay? Yeah. So you can see it's now like spreading through the volume, right? It's spreading inside as well, which is cool. That's what we want for this sort of thing. But this one lingers a bit longer. So we actually don't want the conservation to be so low. So we're going to increase this conservation over here. So increase the conservation to like 0.9. We want it to just stick around for a while. Why is it doing this? It's just jumping to frame 80. Like, chill. I'm actually going to remake that solver because I think it's broken. So just like that. Okay, conservation. No, it's still going to 80. Okay, I don't know why it's going to 80, but it's fine. So conservation, like I said, 0.9. We can take a look right now. Okay, so as you can see, like slightly better conservation, right? What we also want is to remove those points when they've been used, right? And we're going to be converting this to a sort of volume, but there's a nice way to do this. It's a pretty cool way. First thing that I want to do is actually make some adjustments, because if you look at the actual volume, there's some nice variation in it, right? There's like areas where there's a bit of noise to it. That's kind of what I want. So I'm going to add an attribute noise. And this attribute noise, I'm going to put inside of the solver, but I'm just going to like do a little bit of a test. I don't know why it's going to 80. Who knows, man? I have to keep pressing escape now, which is kind of not very cash money. So where did my node go? Attribute noise. I don't know where my attribute noise went. In here, we're going to vary the intensity, right? So it's a float, and we're going to do a zero-centered add. So zero-centered just means it goes from 0 up to 0.5 and down to 0.5. So negative 0.5. That just gives it like, when it adds, it either adds or subtracts, right? It can go either way. And so we're going to do a simplex noise. We'll play around with these settings, but we're going to take this attribute noise, go into our solver, plug it in before our attribute wrangle, just like this. So now intensity works a bit differently. And I'm actually not going to be using that add. I'm going to be using multiply. So we want to multiply at each frame by a random value. So sometimes it will multiply and stay as it is. Other times it will multiply and reduce. So certain areas will sort of like have different effects. Will the live be saved? Plus chat? Yes. Okay. Because 80 people are watching. Yeah, man. Ominous. Okay. This is the weirdest thing. If anyone knows why it's doing that, I'd love to know. Okay. So now our intensity gets multiplied by a random value every time it activates. Bro. So that might be a little bit too low. We'd have to make a couple of adjustments. We kind of want that a little bit better. So I'm actually going to go to my settings that I used. I don't want to like have to play around with these things too much while you guys have to watch. So this is what I did. I see. I have it as positive because you don't want the values to be extremely reduced by this. Then I remap the range. so that it generally increases it. Right, so for the most part, it's increasing. This ramp is just saying like the lower end of the value that comes out, so that'll be like 0, versus the higher end. What's the distribution? Is it like all low? Is it all high? So we're just kind of increasing the amount that high values show up. And this is driving me insane. This over here, we'll put after. So once it's calculated the intensity, it will multiply it by the channel noise, by the attribute noise, and you'll get like some variation. So that's kind of working. Maybe not as obvious as I'd like, but I'm going to use another attribute wrangle over here, and now I'm going to use that cull attribute. So this is actually where... Always something, man. This is ridiculous. Why does it just want to do until frame 80? And I can't place a new node. Okay, guys, I'm going to close this file and reopen it. I don't know what's going on with that. That's very weird. So let's do that. In the meantime, I'll check chat. Can you make this effect as shader? Yeah, most of us is shader driven. Also came from Max, caught in Houdini, Vortex of Intrigue. It's a good way to put it. Video killed the radio star. One thing that would be cool, the twins effect. Yes, I actually tried doing that. Surprisingly difficult. Didn't do a great job of it. But yeah, it's tricky. It's actually like there was an article on side effects about how they did that effect. And it's pretty hectic, man. There's like millions and millions of particles that they have swirling around, and they do divergence of a pyrosolver or something. Oh, is it working? Could it be? It doesn't just want to go to frame 80 anymore? Oh, joy. Nice. See, guys, sometimes just gotta restart. Is it because I had my renderer open? I was calculating the 80th frame. I might be an idiot. You're right. I might be. Yeah, I could very well be an idiot. That might be. Okay, so we're going to use that cull attribute. If at cull greater than 0, then remove point 0, comma, at pt num. So now it's removing like a chunk, right? So that's pretty cool. Just removing that chunk as it's going. And so now we can do some interesting stuff. But before that, I actually just want to increase this intensity, the amplitude, to 1.5 over here. And I want to see what that does for us. I think that might be a bit more interesting. Yeah, that's a bit more interesting. So now we're getting kind of what we want from this, is that sort of slow fade off. And some of these areas are staying alive because of that noise value. Now, we don't want that noise value to be constant, right? So keep this in mind. Noise is based on position in space or position in general. So like if this is your positions, so you have a bunch of positions like X and Y, if your noise occurs somewhere, it'll occur across those positions. So anything, so like, how can I explain this best? So if your positions change, the noise changes, right? So if you move your object across the noise, so like this is moving across and this edge moves to like here, then, oh, steady hands, steady as a surgeon, then it like sort of slides along the noise. That's often an issue you have when you try doing like sort of noise-based texturing, is that your noises slide across the surface. Looks pretty bad. So the other thing that you could do is you can animate the noise so that it changes as like progresses over time. So it's no longer just dependent on position, it's also dependent on time. So that's what we're going to do. Go in here, and to do that, we just go down here. We just say animation, animate noise, sorted. So now it looks something like this, where certain areas exist. It's like keeping certain areas alive, but it's moving over time, right? So it's never keeping the same area alive for too long. Cool. So it's like eating away at this. But now we want to do some extra stuff to this. So I'm going to drop down an attribute blur. this is pretty nice for just sort of like smoothing off the effect a bit. So we're going to base it on proximity. We'll just do like a 3. The other thing that this does is it stops our volume from exceeding the bounds of our geometry, right? Because we don't want to see the volume before this breaks up. So by attribute blurring, we're kind of tightening everything, pulling it in. So yeah, we have this now. And what we're going to do is drive density and color. So I'm going to remove that quickly and drop down another attribute wrangle over here. In this attribute wrangle, we want to affect a couple of things. So we're going to say that at density, and you can do some more interesting stuff with density, but I'm going to do it fairly simply. And I just want to make sure, I don't want to lie to you here. I don't want to do the wrong thing. Yeah, okay. So at density, you just set it to 1 to start with, right? So everywhere, it's completely dense. So it exists everywhere initially. And then you say, if at infect equals 1, so if the current point is infected, then at density times equals at intensity. So now we're sort of taking all of our density values all over and toning it down by our intensity value. So density is getting multiplied by intensity. And so we can take a look at that. If we just drop another color node, we can check what our density looks like. If we just run from attribute, density. So that's kind of nice, right? Like that even starts to look a bit like a volume. The other thing that we want to do is give this a color. So we're going to give a color, v at cd equals channel ramp. And we're going to drive this by a noise. So I'm actually going to create another attribute noise over here. And this time, we're just going to change it to a float. And I'll leave it as CD for now, because I want to test some things with it. So I'm going to change it to Wally Cellular F1. By default, it does have some fractals. Fractals are just like interruptions, basically. It's like, how can I explain it? It's basically just adding more detail to your noise. That's probably the easiest way to understand it. So by default, Wally is just like a hexagon, and then when you do fractal stuff, it like distorts it. So we can use Wally over there, and maybe decrease the element size to like 0.5. That looks kind of cool. And then we can animate it. So we'll do animated, wherever that setting is, animation, animate noise. So now, as you can see, over time, that noise moves about. And so we don't want it for CD. We'll just have it as an attribute called like CLR underscore noise, right? Because we're going to use it for a color noise in the attribute wrangle. Over here, we just do something like CLR, comma, and then what you want to drive this ramp by. So it's going to be color noise at color noise. And then what have I done wrong? V at CD, CH ramp. Float, channel ramp, string, float. Why is it not happy? Surely it's not this, right? Oh wait, no, I didn't set my display flag on it. Guys, I swear, I do this for a living. Yeah, so now we change our parameter interface to be a color. And now we can give it some colors, right? Whatever colors you want, this is where it gets kind of fun. If you look at the actual effect, there's a lot of blues and pinks. It's sort of, what's that? That style. It's like Neon Tokyo. It's that sort of style. It's these shades. There's like blues and pinks. So not really red, but like maybe an orange. Or like a peach color. Those colors are kind of in there. So yeah, just add some colors that feel right. Whatever feels right, you know? And what we're going to do, it's actually kind of nice to do this, is we're actually going to extend the amplitude of this over 1. So by default, this will generally go between 0 and 1. And if we change this either to 0-centered or we increase the amplitude, you end up with this, right? Where it sort of like repeats itself. Because there's values that are no longer from 0 to 1, it's like 0 to 1.5. So what happens is it no longer falls in this ramp. So it goes like 0 to 1 and then 0.5, so it starts again. and you end up with like really interesting shapes when you do that. So we can just play around with our colors. This is actually such an ugly color. We'll make that like a bright pink. Let's do like a dark blue in here. It's nice to have a darker color. Oh, that looks nice. That's cool. Yeah, it's nice to have a darker color because what ends up happening is you can use this for emission intensity. And what ends up happening is the dark areas don't emit as much. So it's almost like there's lights sort of moving around in dark areas, makes it feel a bit more cosmic. So now we can rasterize those attributes with a volume rasterize attributes. And then the attributes that we want are density. We created that earlier, and CD. So that's taking a little while. Oh, voxel size and particle scale. Once again, I'm going to refer to my actual file because these are things that you kind of need to tweak. So I did 0.01 and 0.015. Basically, that's actually hideous. Why did I do those settings? Okay, we'll do it for now. Particle scale will increase here. So this is just like how big each particle is considered. Voxel size is like the resolution of the volume. So if you decrease this, you end up with a higher resolution volume. And then each one of these points has a sort of field around it of 0.02. So that's kind of nice. That works. You can also do like VDB blur stuff, things like that, if you want to. I don't know if I did. I didn't do that, but you can. So yeah, what I would suggest is increasing the scatter points so that you have more points to work with when it gets converted to a volume. And like that will generally take a little bit longer, but it'll look better. So let's just go to like frame 36. We check that out, it's eating away, but we can't really view our color. So we can use a volume, what's it called? Lads, I forgot what it's called. Visualize, volume visualization. Plug that in right over there. And you can do a density field, just density. And then down here, you can do a diffuse field of CD. And there you can kind of see what we're getting, right? It's now a volume from points, which is pretty awesome because we can avoid doing pyro stuff. Generally, you want to just like avoid dynamics unless it's completely necessary. If you can make your life easier by avoiding dynamics, then do. Like, why not? As long as it just looks good. At the end of the day, it's all visual, right? So it's like, doesn't matter what the technical side of it is. Just like get to the end result. That's actually an important thing. I think a lot of beginners get very caught up in the technical side. But really, at the end of the day, like if you're working in a studio or something, all that they really want is something that looks good. Unless, of course, you need to like hand your tools over to someone else, then maybe make it nice. But at the end of the day, you're just trying to create something that looks good. So if it works, man. But this type of thing is pretty cool because you can actually take this exact thing, give it a heat field or temperature field, and put it straight into a pyro solver, and it'll go poof up. And then you can use a collider and invert the sign field so that it's contained inside that, and then break the collider so that the smoke is released. Then it's like kind of next level, then you're really doing something pretty cool. So if anyone wants to do that, feel free. But I'm just going to do it like this. I'm going to drop a null, and this null is going to be our volume. Volume out. We have our volume out and our geo out. So what I'm going to do is no longer use this disintegration node. This will be like our work node, basically. Over here, I'll drop a geo node, and I'm going to check chat in a second. So we'll do this for volume render, volume render, and attribute geo. And this one's just going to be geo render. So now we can object merge those things in. Object merge in our one thing that is our geo. So see, this is why it's nice to have them capitalized. They just show up at the top, right? You can see exactly what's important. So geo out, grab it over there. Volume, object merge, and grab the volume. So volume out. And one thing about our volume, oh, it's sticking through his head. Oh no, bad times. So one thing about the volume is we just need to give it a material. So I'm going to give it the material in here. You can do whatever workflow you want. Like don't be too bothered by it. So materials, I'm I'm going to add a material into this material network. So we can just like choose Disintegration, and then I'll make one called volume. So I'll just, it will be there. Doesn't exist yet, but I'm going to go make it. So in here, do an rs mat boulder, call it volume, dive inside, and remove this. We're going to use an rs volume, rs volume, right into volume. It's got some settings on it. Nothing like particularly complicated. Density is kind of like a thickness, right? How much, how many C's it has. Is it like 3 C's thick? How thick is it, right? So it's like just how dense the thing is, the cloud. You can think of it like very sparse clouds versus like a cumulonimbus, big poofy ones. And then absorption is like how much light is absorbed. This one's kind of like it kills the light that's coming in, which is nice for getting things looking kind of mean, like where you just get nice edge light and stuff. So those two work hand in hand. Like if you increase the one, you generally want to increase the other, unless you're going for like a particular look. Then there's emission down at the bottom. So I'm not going to use anything for absorption coefficient. I'm just going to change its color. So density, that's cool. Color channel, we'll do CD. Once again, down here, we'll do CD. And emission, we can actually use density and then drive it by CD. So CD is like the, we're using it as a tint color. So it'll just change the color of this. If we take a look at this, maybe it'll work. I don't know yet. It might, hopefully. We can hope. Let's do this, Redshift, open render view, and take a look at what we have. My mouth is getting really dry, guys. I'm starting to make like gross mouthy noises. Not bad. All right. Looks okay. So as you can see, like, it doesn't look like it's fading much. Maybe more fade would be nicer. Yeah, I think it needs to fade a bit more, but it doesn't look bad. I don't think it looks bad by any means. Maybe I'm not allowed to say that because I'm the one who's making it, but you can see like it's getting eaten away there, right? You can do like volume smoothing to get rid of those little, see those little circles? You can smooth the volume, you can like blur it, you can do a bunch of stuff to it. There's a bunch of ways to just make it look better. As you can see, there's also this issue where the volume is coming through the geometry. That's why I said like increase the resolution of the volume, so of the ISO offset, increase your scatter points, and then do this attribute blur to sort of pull things in, tighten it up. So we're looking pretty good. Might make a couple of changes to the volume. I think it would be cool if there were, you know, a little bit more variation. It's always nice to have a little bit of a more interesting color going on. So we can mess around with some settings here. We can try decreasing both of these. So decreasing that over there, that over there. Now you can see it's more like emissive rather than dense. Can maybe decrease this. But yeah, you can like play around with this. Like that looks pretty nice. Pushing that up. So that's maybe not like the actual effect, but I think it looks kind of cool. So we can see. Yeah, like it's starting to get there, right? I hope so. I haven't looked at chat. Maybe you guys are like, ugh, it's hideous. I hate it. Chat, what's up? Talk to me, y'all. Vaporwave, that's what it's called. I don't know what I called it, like Neon Tokyo or something. Yeah. This is so nice. Thank you for doing this live for us. Awesome. It's a lot of fun. I'm glad you're enjoying it. Apart from the dry mouth, it's awesome. You do, what is this? How do I loop the infection so that it repeats on the geo forever? So that's gonna change the way that it functions, like at a more, what you can do actually is you can reset the infect value once they're all infected or something like that. But yeah, like that's one of the options, I guess. Otherwise, I don't know, it's tricky, man. Just because the actual setup isn't sort of inclined that way, but you can do it for sure. I don't think it's too different from what we have. You make some minor adjustments. Wow, you look so different to what I'd imagined. Yeah, I've been getting that a lot recently. I I look like a little boy. It's hideous. I hate it. Thanks, Sam. That's the kind of supportive community that we're fostering. Uh, yeah. So, okay, you guys tell me. Do you want this to keep going on? And I can do like the Spark stuff now, or would you prefer this to be done next week, Monday? I think just let me know now. Warning, if we continue, I might take like a 5 minute break just to like stand up so I can feel my legs again. Mustafa's in. No. Finish it now. Okay, yeah, yeah. The pressure's on. I'll finish it now. Now, please. Yeah. Okay. Cool, cool. Um, yeah, give me like, would you guys mind giving me like 5 minutes? I'll stand here and I'll reply to chat, but I would like to just stand for a bit. If you feel like it, then do it. Yeah, man. Like, I'm easy. I actually covered more than I thought I would, so that's pretty nice. I don't mind doing it now. Um, Depends on how long we have to wait. Yeah, no, like 5 minutes, legit 5 minutes. I'll stand here and still like answer chat. Ugh. It's just so that I don't feel like I'm dying. Okay, cool. Yes, please do it now. Okay, we'll do. Go for a quick run. Yeah, the quickest run. I know you said you're not gonna plug it into a pirate software. Yes, Sam. I did say that, Sam. Don't give me any bad ideas. This is awesome so far. Great. Love it. No, no, 5 minutes, JK. Okay. Uh, yeah. Where are all of you guys from, actually? Now that we have like a moment to just chat. Let me know. Let me know. Why, reason, the name, in between. Um, we covered this earlier. My brother and I, there's 9 years between us. We started a company together. We called it 9 Between. 9 years between us. So yeah. How long do you make money from Houdini? Um, it's been, let's see, like consistently 3 years. Vancouver, Canada. Nice. Brazil. Oh, where? Oh, let's see. San Francisco, Mexico. This is awesome. You guys are from all over. Korea. Awesome, awesome. Um, Man, I'd love to visit a bunch of these places actually. Like, um, I was checking out Vancouver on Google Earth. That's always fun. Um, Nepal, man, this is crazy. He's going to buy cigarettes. He's never coming back. But that was actually all I needed, guys. Oh, Canada, Calgary. Awesome, awesome, awesome. So many cool places. Um, do I smoke? No, no, I don't. Um, I I don't know, never really appealed to me. I don't smoke, I don't drink. I don't think my body could handle any other abusive substance other than visual effects. 16 from Germany. Yo, Fido, welcome back. Awesome. Oh, you guys okay? Isn't like I saw there was like pretty hectic floods going on in Germany. How are you doing? Hope you're keeping safe. Do you work remote for a studio or are you freelance? Freelance. Um, so my brother and I work together generally on projects. So he'll do modeling texturing I do simulation stuff. Hey neighbor. Okay. I think I'm ready to go, lads. I started Houdini with your Houdinis and Scary series. Awesome. Thank you for making them. It is a pleasure. That series really like popped off, eh? That was cool. Um, it was, yeah, it was like, I realized that there was no easy way for me to get into. It's like coffee not ended, bro. It's basically frozen. It's iced coffee. It's disgusting right now. I take tiny sips. I'm like a cat, something. Cats don't sip, they lap. Where was I before I went on that tangent? Houdini isn't scary. I didn't have like an easy way to learn Houdini when I started. So I was like, man, I should really make like something that's just easy, eases people in. So I was like, yeah, let's do it. Okay, let's get back into it. We're gonna do some parts of Ethiopia. Wow, people really are from all over. That's so cool. It's so crazy to me. Yeah. Okay. Oh, how many years have you been working in Houdini? Double exclamation. I have to answer it. It's been 5 years. So it was 4 years in Blender before that. 5 years in Houdini. I've been like doing consistent sort of Houdini work for like the last 3 years. So yeah. I'm still. It's kind of surprising. Like, will you post again on Patreon? Yes, yes. I've got a massive series actually. Oh wait, I'm gonna give you a sneak peek. I got such a crazy series that I've been working on. It's been like months in the making, but I don't want to release it until it's like perfect. So let me see what I can show you of that. It's kind of cool. So I forgot what it's called. Let's see. What can I show you? Where are the videos that I've saved of this? Patreon videos. I legit cannot find this folder. Okay. Never mind, you'll just have to trust me on that one.
Give me show the watch video.
Show the what? How do I do that?
Give it to me in USB. I'll put it on USB.
Oh, okay. Where's the USB? Right. Enjoy. Okay. My brother's fetching the watch video. The like, it's gonna be like the trailer, basically. Posture check. Yeah. Okay. Let's go. Okay, back into our disintegration thing, which is now not just disintegration, it's pretty much everything. It's becoming a bit of a mess. Sorry. I don't suggest you work like this. Definitely be neater than me. If you're gonna learn how to not do something from me, let it be how to not set up your nodes. I just make messes everywhere, and then I come back in a month's time and I'm like, what is going on? Okay, so to do the particle stuff, let's see. How are we going to... I just want to check, quick overview of how I did it. Yeah. Let's see, okay. Pgen, point jitter. Okay. Cool, got it. So let's go. I'm gonna put it over here. So we got our solver, and we know that this is giving us like this edge stuff, right? So we can still use that, because obviously we want to emit particles from the leading edge. So we can take that and plug it into a new attribute wrangle. And this attribute wrangle, we kind of want to remove points. So if at intensity is not maximum, so it's not 1, right? If it does not equal 1, remove the point. So we're only getting like the sharpest point of that leading edge. So we just say remove point 0 comma at pt num. Right, that's the idea. So as you can see, some reason, oh yeah, let me just hide other objects. So now you can see we're just getting that leading edge, right? So I'm sure you can imagine that this is nice, this is useful. What we're going to need to do is do a pgen, so that's point generate. Because as you can see, we don't have many points, right? We have some points, but not enough. So pgen, this generates points per point if you say compute number of points. You can see points per point, generate some points. We're just going to generate like three points per point. We want to copy the source attributes. That's kind of important. We want to keep a lot of the information that we're getting from this. When you do this, you have all of these attributes, but if you pgen and you don't copy, you lose all of those attributes. It's nice to keep them. So just keep those, and then we can do a point jitter. So jittering points, you're just kind of fluffing them up, right? Not so much though. We just want a slight bit. So like 0.01 maybe. Okay, and then we're going to go ahead and add another attribute wrangle over here. And we're going to do some velocity stuff. So we want velocity on these points when they're moving along, right? So to do that, we probably going to use normals. But before we get there, let's just create a multiplier. So we're going to do float mult. It's always useful having a mult when you're working with like velocities and things, because it's tough to just guess what your velocity is going to be, if you get what I'm saying. Like sometimes it's a bit high, you kind of want to just adjust it down or push it up. So having a multiplier is really useful. So chf, we'll just call this mult. And now we can, how do I want to do this, actually? Yeah, okay. So we're going to use the normals. So we're going to need normals on our flippy. I don't believe that they are. Oh, there is a normal attribute. Okay. So if we take a look at our points, they all have a normal attribute that's facing away from the surface of our geometry. Super useful because particles are going to shoot away from the surface. However, they are very boring. So what we want to do is go to our attribute wrangle and use this, but kind of adjust it. So we're going to use some attribute noises and things. But the first thing that we're going to do is just a very basic float rand equals, maybe I shouldn't call it rand. I don't want to confuse anyone. So float randomizer, because there is a function called rand. So this one will do fit 0, 1. In here, we'll create a channel ramp. And we're going to call it vel for velocity. And we're going to drive it by rand at pt num. Outside of the brackets, comma 0, comma 1. And we'll change that now. So fit 0, 1 fits a value that's already between 0 and 1. So we know that the rand function always returns a value between 0 and 1. So if you use fit 0, 1, it's perfectly fine, because you're always going to be getting a value between 0 and 1 from whatever this returns. So we can then fit it to a new range. So our new range will be 0 and like 5, right? So it'll give us a random value, and instead of it being from 0 to 1, it'll be 0 to 5, so bigger values. We can then say v at v equals v at n, right, times our randomizer times our multiplier. Right, so we're just saying like multiply it down by all of these extra things that we now have. So our multiplier, and let's just set this over here. Why do I not see anything right now? V at n. Do I have, oh, bro. Fit 0, 1, float randomizer. I'm going wrong somewhere. CH ramp. I'm going to quickly look at chat in case anyone's like, I know. Okay. CH ramp, vol, rand, IP. Oh, I'm so silly. Outside of this bracket, 0, 5. Okay, nice. So now we still don't have velocity. Interesting. Equals v at n times randomizer times mult. Vol times randomizer times mult. Interesting. What am I doing wrong here? Let's see. N? Do I still have n at this point? I don't. I lose it along the way. Ah. It's always something. Point jitter. Update normals. We don't want it to update normals. Don't do that. We want the old normals, right? So we fetch that. Now we're cool. So now you can see that we have this velocity, right? And it's being generated by this over here. We can just pull this down over here. As you can see, this gives us pretty good control over the random velocities, right? So if we pull this up, you get like fewer high velocity particles. If you pull it this way, you're increasing the distribution of low, like, yeah, it's basically, how do I say this? I mean, I think you guys can see what's going on here, right? So if you just put it at the bottom, you're kind of clamping all of the low values. So you're removing low values, removing pretty much everything. And so you can very easily control your velocity with this. And then you have a multiplier if you're happy with it, but you just want it to be dampened like entirely. So I'm going to do this probably just like straight out of my file over here. I had something that looked like this. I had very few high velocity particles. Most of them were like low to medium. So most of them were low. Some of them were high. Just like that. Okay, so you'll see why this works nicely. These are just velocities. As you can see, they're random as this thing grows out, which is pretty cool. The last thing we're going to do for this is an attribute randomize. So noise, attribute noise, not randomize. Randomize is just like completely random. Noise is based on a pattern. So we can do float and v. Well, not float, vector. Vector, v. And we're going to want to add some zero-centered noise. Remember earlier I said zero-centered can be like negative or positive? So yeah, we're just going to add a little bit of noise to this. And that should look good. I'm just going to check my file, how this looks. I just want to make sure. Okay. Let's take a look at this. Yeah, sure. That looks about right. Just checking one more time. Right. I'm going to decrease the element size on this though. So it's just like how big the actual noise pattern is. And we don't need to animate this because it's already changing like as it progresses. So that's fine. Now, PopNet, the fun stuff, right? So into a pop network we go. Right in there. In here, you're going to have all of these stuff, all of these things by default. We don't need like anything complicated here, really. We want gravity. The actual effect, you can see that there's a fair amount of gravity. And I do recommend constantly checking back to your reference material. Wait, spoilers. Okay. As you can see, it's like the particles, they fall a fair amount, right? They shoot out, but they also fall quite a lot. So that's kind of what we want. We want the particles to shoot out and then fall. So we have gravity, but we're probably going to decrease the gravity amount. We'll see. So, right, I'm going back to my file. These are all like little settings that I discovered works nicely. So that's why I keep referring back to this. Pop wind. You're going to need a pop wind because there's a lot of movement once it flies out. That's what pop wind is really nice for. Amplitude of 2. I'm going to do a swirl scale of 0.35. Once again, these are just settings that I found worked well. Oh, the actual source. We need to change how it's sourcing. By default, it scatters onto surfaces. That won't work if all you're bringing in are points. Because if you're bringing in points, there's nothing to scatter onto. So you have to say either all points or points. Can't remember what I did. I used all points. Okay, so we'll use all points. I don't know. Maybe past me knew better. So yeah, over here, we can just go down to our life expectancy. So we'll change that to 1, and our life variance to like 0.5. 1 is actually 24 frames. So this could last anywhere from 12 frames to 36 frames, because it's 1 plus minus 0.5. So if we play this back, you end up with that, which isn't right. It doesn't look great just yet. So we're going to make some changes. Like, it's not bad. The movement is there. It's getting there. What we'd like is to decrease the timescale. So timescale is like you're going in slow motion, right? If you look at it, wherever that is, if you look at this, it looks like the particles aren't flying at real time, right? Then they don't look weighty. They look kind of lofty. They sort of float a bit. To get that looking like that, we can drop timescale. So timescale, let's see, let's mess around with it a bit. 0.3 according to what I tried, and you'll see that this slows things down. What it also does, though, is that it makes your particles live longer, because you're saying, okay, live for 1 second, but 1 second is now slowed down. So what you need to actually do is you need to take your timescale and you need to multiply it by these values. So you can just right click over here, say copy parameter. Over here, you can multiply, so just press times, paste relative reference, and then over here, you can do times, paste relative reference. So now it's multiplying it by your timescale. So your particles don't live as long. You can see now they look like a lot more lofty. They float a bit. Looks a bit better. A bit better. It looks a bit better. So yeah, gravity might still be a bit high. So drop that to like -4. There we go. Okay, so that's starting to look good. That's looking decent. The thing that we want to do next is kind of decide how we want to separate these particles. Because if you look at the actual effect, there's some small particles in the actual sort of, as like the disint. Sorry, on YouTube. There's like particles as the disintegration happens, but there's also these ones that fly out. So we kind of want to separate that into sort of scatter particles that are like the close ones, and then the hero particles, the ones that you actually kind of focus on and see properly. So to do that, what we can do is drop an attribute wrangle right over here. And we're going to do a couple of things in here. The first thing I want to actually do is work on the color. So we're going to work on the color of these things, right? I think that's a good start. So to work on the color, we're going to need an age ratio. So float age ratio equals 1 minus, and then in brackets you can do at age divided by at life. The idea with this like at age divided by at life is at age is the particle's current age. At life is how long it will actually live for. So this will always be a value between 0 and 1. Like if it's lived for 0.1 second and it's expected to live for 1 second, then it's lived 1/10 of its life. So this will be 0.1. And then we say 1 minus 0.1, so it's like 0.9. So that's just age ratio. That's very useful for doing color stuff. So we can say v at cd equals, and we can do a color ramp. Oh, channel ramp. Sorry, not color. Let's call this CLR for color, comma, and then rand at ID. So it's driven by random values in, by our ID. PopNet generates ID. So you can see each one of these points gets a random color. If you don't use ID, if you use something like at ptnum, point numbers change every frame because points are being added. So always use at ID because ID stays constant. So like 0.1 might be 0.24 next frame, but ID1 will be ID1 next frame, and the next frame, and the next frame, so it doesn't change. So that's nice. So that's one thing that we do. Next thing, we say v at cd equals, actually no, we want a times equals, so we're kind of tinting it now. So we're saying channel ramp, and we can give this another sort of name, call it tint, and over here we can drive it by that age ratio. So age ratio, just like that. Create our spare parameters. We have color and tint. We need to turn them into color parameters. So go over here, color, ramp, color, apply, accept, and now we can give them color. So the random colors will probably be things like reds, blues, whites, pinks, those sorts of things. Same as the other stuff, vaporwave, right? Think vaporwave. And so we're just doing those colors like that. Maybe a bit of an orange in between. So now our particles are going to get that random color, but only if they get tinted. So we want to tint over time. So as you can see, we have it the wrong way around. The particles are starting dark and ending light. We want it the other way around. Starting light, ending dark. And we can choose what sort of taper we have on this. And we can also change what sort of color they experience over time. So maybe you want them to sort of go towards like red, right, as they're fading off. So you can do that. This is pretty nice. Like you have pretty good control over here. So random particles get random color over time. They fade. They get tinted by this color over here. And so you can see what that looks like. Right now it's kind of boring. But, you know, maybe it's not that boring. I don't know. It's kind of cool. The other thing that we're going to need, I just want to make sure of this. I'm just checking quickly. Yeah, okay. Okay. So we want to now separate this into these sort of fast-moving hero particles and these sort of slow-moving ones. You see how the slow ones sort of like they clustered together? So we want those to be smaller, and we can just use like basic particle instancing for that. But for the other ones, we actually want to use proper geometry because we want them to look good. So what we can do is, before all of this, we can group some particles. So over here, if length, oh wait, no, I just need to say if length v at v. So what this does, it's kind of interesting. This is very cool. So if you want a vector sort of represented as a scalar, it's sometimes tricky working with vectors. So vectors, as you know, let me just go over here. Vectors are 3 values, right? So they could be like positive or negative. That's why it makes them so hard to work with. Like if you wanted to know, so say this is your velocity, right? Or maybe that's not a good idea. Maybe this is your velocity. So we know that this is a little bit to the left. So it's like x equals negative 0.1. And then y is like straight down. So y would be, y would be like negative 0.9 or something. And then let's say we don't have any z value, just to keep it simple. But you want to know like how hectic is this sort of push this way? You might want to do something like, is my velocity, so is v, greater than 1, right? And like, if it was going this way, it would be true. Because those are all positive, right? This is moving towards the positive direction, this is moving towards the negative. But it won't work because of this, right? These are negative values. Basically what I'm saying is you kind of just want to find how much it's pushing in a particular direction, not the actual direction. So you kind of want to negate these negatives. To do that, you use length. As far as I know, length just does something like x squared plus y squared plus z squared, and then it roots it or something, so that you end up with positive, because minus 0.1 times minus 0.1, oh, that's the 10, gives you a positive, right? Same with 0.9. So that's exactly what you want. Instead of getting a negative value, you get an absolute value that's giving you like the amplitude, the magnitude of your vector. So the length is really useful for working with vectors. So if we go over here and we say if length v at v greater than some value, and I'm just going to guess over here and say 2, then put it into a point group. So we'll say set point group, and the group will do 0. So this is just the geometry stream. And we'll call these hero underscore sparks. So hero is just the term that you use for anything that's sort of a focal point in a scene. Like if you're doing a big destruction simulation, you might have a bunch of like broken pieces of rock in that, but you might also have a hero rock that falls close to the camera. So all of those in the background will be like low res, and then the big hero rock will be high res. So just hero is just something to keep in mind. It's just the terminology. And then we'll say at ptnum, so put point number into our group. 1 is just saying yes, we want it in the group. 0 would be no, out of the group. And we say set. So I actually just want to check what it's adding, because it should add very few points. So we'll see. Let's do a color node. We'll just color the points that are that have a high velocity. So anything in hero sparks will make red. Right, cool. So you can see there's like a couple of points that have high velocities. You can actually check, like these are the ones that have these really long streaks behind them. And so we can increase that amount by changing this to like 1.5, right? But this is what's so cool about it. Even negative values, like it ignores the negative value because you're getting the length. So that's really nice. Pretty cool technique. Keep that in mind. So yeah, we feed that into the PubNet, and it actually keeps those groups. So I got rid of that color node. Okay, but yeah, so it keeps those colors over there. I mean, the groups. So as you can see, all of the ones that are like flying out pretty far are getting grouped because those are the ones that have high velocity. So those are our hero sparks. So that means that we can then adjust them separately to everything else. Okay. May take like 2 minutes. Just look at chat so I can breathe. Oh, right. The USB stick has returned. Hello. Hello, USB stick. Yeah, so hope that wasn't too loud for you guys. Jeez, that's really loud. Is this? No, it's this. This.
Yeah.
Yes. Oh, that's loud. That's cool. Yeah, so this is actually the intro for that thing that we're doing on Patreon. Been working on it for a while. The whole idea, okay, I'm going to give you the breakdown of the idea. This is like, you guys are the first to hear about this. The idea is we're making a series that goes from like complete beginner stuff in Houdini to like the super, super complicated stuff. The idea is to turn you into a Houdini artist. So you go from beginner to working in a studio, right, in the course of the course. And so it starts with basic stuff like modeling, some basic Vex stuff, sort of proceduralism, all of those things. And then we move on to other stuff, but it becomes more of like a general course. So you become a Houdini generalist. So we'll do like Kineeffect stuff. We'll do fur simulation. We'll do particles. We'll do flip. We'll do everything. But the way that I've broken it down is that it's only what's easy as a next step. So it's not like we go from modeling to flip dynamics. We go from like modeling to pop networks to like vellum, and then we start touching on flip, right? So it's like just a nice little gradual curve. This is the clip of the first thing that you make in the course. It's a watch. Yeah. So yeah, that was all done in Houdini. It's even rendered in Houdini. Like that's Karma. That's a Karma render, if I'm not mistaken. Yeah, it's a Karma render. So yeah, that will be coming in like a month to a month and a half. As soon as I have time to finish the first module, then I'll release that. And yeah, everything in Houdini. The only thing would be like some texturing stuff because Houdini doesn't really do texturing. There'll be some texturing stuff that's not Houdini. So there might be like the watch face. I do that in Photoshop, but then I'll provide the file to everyone so that they can use it. But yeah, what do you think about Karma? It's cool. I think that they're going to be improving it a lot in the next release. Yeah, it's nice. It works really well with Lops as well, with Solaris. It's like a really nice workflow. Solaris is cool, man. Like, you'd think that maybe as an individual artist or like a small studio that you wouldn't really use it, but there's a lot of power in it. It just makes your scene assembly really nice, like really smooth, well formulated. It's pretty cool. Okay, yeah. Maybe using pop drag. Okay. Oh, this one. Why not use a pop drag instead of decreasing gravity? It's basically just because I like to be able to control all of the forces separately. Pop drag dampens everything, Whereas like decreasing gravity, you still maintain that initial velocity that's so cool. And then like the gravity fall off is kind of nice as well. So yeah, it just gives you a bit more control. I don't know if anyone has said this before, but your voice is calming. Thank you. Even when I'm not breathing and about to like pass out, it feels good. Really appreciate not showing how to do something, but why to do it and how it works. Yeah, so that's like my whole thing. I just really want to teach people how things actually work in Houdini. Only available in aficionado membership, I think. Yeah, it will be. But we're thinking of doing a thing because we haven't released stuff on Patreon for a while. We want to kind of make it like the people who have supported us already will also get access to the course. Just because it's like I don't want to feel like I don't appreciate the people that have been providing support on Patreon. It's just like it's weird. There's like this weird sort of contrast in that you really want to give people content on Patreon, but it takes time making really good content. So you kind of put it off and you end up not giving content to Patreon. And like, it's kind of upsetting. Like, I'm actually kind of upset by that because I would really like to just show my appreciation by putting out really good stuff for the patrons. It's just, yeah. So hopefully this course does that. That's the idea. Cool. Let's go back into the thing. This thing. We're almost done. Surprisingly. It's been 2 hours. That's actually not bad. I thought it would take longer. 2 hours is okay. So I'm pretty happy with how I explained things. Hope you guys are having a good time. Yeah, and of course, once again, this will all be saved on YouTube. You will be able to watch it. I think chat takes about a day for YouTube to like process and put on the side. So there won't be chat initially, but by tomorrow this will be on YouTube. So yeah. Let's go. Do I think Comma will replace render engine like Redshift, Octane, and Arnold? No, I don't think so. I think every renderer has their like pros and cons. People always maybe prefer Redshift for some reason, or maybe prefer Octane. And like, yeah, the thing with renderers is it's oftentimes partially personal preference, but also like what they're really good at. Some renderers are just good at certain things. Like Redshift's really nice for just like commercial shots. Like say you're doing stuff for TV ads or like product shots. It's really nice for that. This tutorial's amazing. Thank you so much. Thanks. I really appreciate that. I appreciate that I can spend my time in a useful way. Okay, so let's continue. So we added that group, and now we can do some extra cool stuff with that group, which is nice. So we're going to add p-scale. P-scale is Houdini's uniform scaling thing, right? So let me just bring this up over here again. Oh, it's becoming a bit messy. Maybe I should just wait to have more space. No, okay, we'll make a new layer. So p-scale is Houdini's uniform scale attribute. So if you're using something like copy to points, or if you're doing instancing, it uses p-scale. It looks for this attribute, right? So like Houdini recognizes this attribute. So let me increase my smoothing a bit. Yeah, okay. So the idea is it's uniform. So if you have p-scale of like 0.1, it's the equivalent of having a vector that's 0.1, comma, 0.1, comma, 0.1, right? Then there's another attribute, I think it's called scale. Scale is not uniform. So this is a float. P-scale is a float. Scale is a vector. And the reason is float p-scale sets the same value for all of the sort of vector values, but vector scale multiplies them individually. So vector scale would be like 0.1, 0.3, 0.2. So that's just something to keep in mind. If you want to scale something individually per axis, you can use scale. If you want to use p-scale, that's generally what you would use. But both are recognized by Houdini. So we're going to use p-scale because basically this one's spheres. So at p-scale equals something that I forgot, equals start scale. So we're going to make an extra little variable. We can call it float start scale. So this is the initial scale, and we'll make it equal to, so we're going to fit 0, 1, and we're going to get a random value per ID. So random per ID, right? And then you want to fit that value between a new value. So between 0.1 and 0.2. So there's a very slight variation between every point. And we're going to multiply that by a channel multiplier. So channel float mult. Once again, mult is just nice to have. I think I'm missing a bracket there. I think I have an extra. Yeah? Yeah, okay. So yeah, we just have that now. Random value multiplied by our multiplier. So we can set our multiplier to 1 just by default. And now at p scale is going to be equal to the start scale, so that variable that we just created, times our age ratio. Age ratio. So the idea is they get smaller over time, right? So they shoot out and fade off. That's the idea of that. So we want the hero sparks to be bigger. What we'll do is we'll just say if in point group. So we're saying if it's in this particular point group, which is geometry stream 0, hero particles, wait, what do we call them? Hero sparks, right? Something like that. Hero sparks. Hero underscore sparks. So if they're in that group, then do some stuff. If in point group, that's all it needs, I think. And you need to check which point at ptnum. Then do some stuff. So the stuff that you want to do is you just want to make your p scale a bit bigger. So you can say at p scale times equals, and we'll do 3, times equals 3, like that. That gives you that. So you can't really see it yet. You could copy to points if you want. I might just do that. I hope that doesn't kill everything, so I'm going to save and try that. Let's. It shouldn't break everything, but I don't know. I might be wrong. Sphere. So points to copy to, geometry to copy to. Yeah, you can see like different scales. 0.1. Yeah. So you can see that they're big when they start, and then they shrink, they fall off. And so, let's see. Right. Okay. So we're getting an idea now of how they actually would look. Cool. So those are what your particles would look like when rendered. So there's a couple of ways to render this. I'm going to drop a null over here, and I'm going to call this out particles or particles out, whichever one. Particles out. We're going to take this into a new node because we have everything separated now, so let's keep separating things. It looks nice. Easy to come back to. Geo. Sparks. And then we'll do another one over here, and we'll do hero sparks. And so in here, we'll just object merge in object merge our particles. So we'll object merge in everything and then just delete the ones we don't need. So particles out, bring into here. And then we'll just blast everything that's not in that hero group. The reason I use blast and not delete is because blast, if you have a group or anything like that, it's a lot faster. The reason delete is a separate node is because it gives you more control. But that also makes it slower. So when you delete with a delete node, it's a lot slower than using a blast node. A blast node is just like, oh, you want to get rid of these things? Cool. It doesn't ask like any questions. It's like, cool, done. Delete is like, okay, which things exactly do you want to get rid of? So blast, we can just say blast hero sparks. Now it's only those small little slow moving particles that we have. That's kind of nice. And then in the hero particles, we're going to do something similar, but obviously not as simple as that. So we're going to grab our particles out. Blast. Almost the same thing. We're saying hero particles, or hero sparks, but deleting non-selected. So now it's just the fast-moving ones. Cool. Hero sparks, I'm actually going to use a copy to points. This is something a bit weird. I would do instancing, but I'm not going to overcomplicate this tutorial. But you can do instancing. Maybe I will overcomplicate this. No, I won't. It's fine. I'm going to give this a tube. So I'm going to just drop its radius scale. Let me actually see what I used, so I can just get this right the first time. Makes it easier. Where was I? Over here. Yeah, okay. So a tube at like 0.25 radius scale gives me that. End caps, just like that. Change it to a polygon. Decrease columns, and then do a subdivide.
Ohana means
That gives me a fright every time. I really need to do something about that. I need to not be so on edge. Um, yeah, so we just subdivide gives us like a nice little particle, like a grain of rice, right? A little jelly bean, and then we can use that to copy its points, and it looks pretty whack. But what's cool is with that you can actually just decrease like everything on this really, and then change the rotation, and it will be fine. So we can drop a transform node, change the rotation. So we'll do 90 on X. I think that's right. So now it flies in the right direction. It's a bit massive to begin with. That's a bit weird. Yeah. So I'm just checking to make sure that they weren't like this before. Yeah, I think I did something silly here. So this was initially... Yeah, I think my P scale was a lot lower in my original project, or something like that. But we'll see. I'm just going to go check quickly. 1 second. Sorry. I just want to get this right for you guys. Yes, my scale multiplier was much lower. So sparks, geo, disintegration. Over here, I had 0.05. 0.05. So they were much smaller. And then I think I like even increased the scale over here to like 5. So now you have these giant rice grains, and they shoot up. Okay, so we can make them a bit smaller. 3, 2, something like that. Right. So now we have those sort of hero particles. They're just the sort of big ones, the ones that are like really the focal point. And then we have the other particles, just kind of extra. And on both of them, we're going to need to add motion blur. So if you're using Redshift, you'll just go over to down here. Yeah, just down here. Mesh deformations from velocity attribute. So we'll do that one. I'm not sure if you have to do this actually, but I'm going to do it. And then you go to your out node, and on this over here, you have to go Redshift, motion blur, enable instances or particle blur. Then a nice thing to add at the end is a little thing that can just control your velocity. So a multiplier. So you say v at v times equals channel float. And this one we're just going to call mult again. I like mult. And yeah, so over here you can control sort of how much velocity these things have. So you can also control your motion blur through this, right? So you can do it in here. It's just nice. You can just have easy control from like where the nodes are set up. And so, yeah, we're going to go to these sparks. And over here, we need to say that these are particles. So you say render object as particles, and then we need to go create some attributes for them. I mean, a material. I don't know. Yeah. RS mat builder. Call that particles. And I think we can actually just use the same one for both. Particles. Jeez, man. Particles. Cool. So what we want to do is we want to fetch the color attribute. So we're going to use RS point attribute. That's the one. And overall, so we're going to put it into emission color. And we can put it into base color, diffuse color. I think that's okay. We'll decrease or increase the roughness on reflection so that they're not so shiny. And then we can go over here, increase the emission weight to like 10. And that should be fine, honestly. So, the particle attribute lookup needs to find the right attribute. So it needs to find CD. So we give it CD over there. And it'll now fetch CD and feed it in. So now we just apply it to our sparks. We can, yeah, I'll create a material node for it. I'm getting a bit clumsy and all over the place. Like, these should all be nicely set up, sort of per node, but it is what it is, man. So, particles. And we'll do one over here. Material. Particles. Cool. So, moment of truth. Hopefully this doesn't look like trash. Sam's just waiting to be like, oh, it's hideous. Oh, it's bright. It's very bright. Way too bright. Okay, settings. I'm going to drop the bloom on this. So increase the threshold over here. Bloom intensity. Okay, it's a little bit hectic. And some of these don't look right. What's going on with those? Oh, only our hero particles seem to be working. Why is that? Redshift, render object as particles, global scale. Yes, I think I might have to put the material over here. Is that correct? Did I do good? Yeah, okay. So yeah, this is maybe a bit hectic. So we can decrease the scale. I think I'm going to decrease the scale of all of those particles. So disintegration, we just drop the scale over here. Maybe on the multiplier. Yeah, we'll do it on the multiplier. 0.1. And I also want to decrease the velocity. I'm noticing that the motion trails are a bit hectic. So I'm just going to copy over this over here, put it into here as well. And same thing. Let me just rerun this. Yeah, there we go. Okay, that's looking better now. So as you can see, there's some cool looking little colors and things that you get in these particles. That was from all of that randomization stuff that we did. As for actual sort of like interesting glow and things, you would want to do that in post effects. So you don't want to do it right now, but you could sort of separate the emission layer. And I'm going to show you how to do that quickly. I'm not going to go into that too much. But that's like the gist of the effect. From here, you have everything that I had to work from. You can do whatever you want with it. Like, I don't know if you just want to change colors and things. Let's just change the angle. Check out looks. So, yeah, like, not bad. You might want to change the number of particles, make your hero particles a bit bigger, all of those things. Those are all options. It's not as tweaked as the one that you probably saw for the announcement. But really, that's like just playing with what's here. It's going to go back a bit so you can see like early on in the effect. Yeah, so you can see you're kind of getting that effect that starts at the center, sort of propagates out, and it should look good. So the one thing you'd want to do is that volume thing that I said, increase the resolution. I'm not going to do it for the stream because it'll slow everything down. I'm not really interested in doing that right now. You can still texture this however you want. That's the cool thing, right? Because you're only affecting opacity and emission. So on this disintegration layer, you can still give all of your textures. So, like I did with the announcement, you can go to disintegration. You can very easily replace this. So I'm just going to bring in my... actually, you know what? I can just show you the actual file. Why am I doing all of this? Yeah. Here's the actual file. And in here, it's called Floppy. It's yeah. My wordplay is genius. Flippy Loki. It's Floppy. So yeah, we made this little Floppy. And it's busy cooking for a bit. So let Floppy cook. And I'll show you this one. So, oh, script error. Nice. Let's close that again. Okay, that's probably because I have the other one open. I don't though. Okay, not sure why that's happening. Let me close the other one and we'll see. And then I'll just go over some render settings and that will probably be that. So let's check it out. Open render view. Yeah, okay, I'm just going to open this file again. But yeah, that's almost everything. Let me just reply to chat real quick. So I leave you guys for the night. Peace out, guys. Later. See you, see you.
Don't forget that the geometry has to shade UV. So UV
Yes, yes. Okay. A quick reminder about this effect. If you're going to do it exactly like I did it, your textures need to share a UV island. It does get a little bit more complicated, not much more complicated. Like you can figure it out, but it gets a little bit more complicated to sort of separate it into different islands, UV islands. So if you have like one UV island for the helmet, one UV island for the body, it's going to get a bit more complicated. But the idea is you still have this textured as you would, wherever this may be. This is a bad file. Don't look at this file. So yeah, you still have it over here. You can see I'm still bringing in a diffuse. I'm still bringing in roughness, metalness, all of those things. And then I'm doing what I did with like what I showed you. And this one ends up looking like this. So this one's kind of nice. Where do you live, bro? It's like 30 degrees Celsius. Yeah, it's cold, man. Yeah, so this is how this one looks. All the same stuff, just like minor tweaks to the settings and that. And so you end up with this. And this is like before post-processing. So I didn't do post-processing in here. I actually did it in Houdini. Oh my goodness, it's a massive window. In Houdini, you can actually do post-processing, which is pretty cool. So I'm actually going to show you that quickly, because maybe it's interesting. Yeah, so like I would, okay, no, it makes sense to show you the rendering first, so you can understand this a bit better. So rendered it out, but I gave it AOVs. So in Redshift, you would go over to Output, AOV, and over here, you can add some AOVs. So you just add one, and you choose what you want, right? So like Z depth is distance from camera. So you can use that to add motion blur in post. But there's other stuff like my volume fog emission, volume lighting, emission, and a crypto matte. So crypto matte is just like a different color for each object. So that's kind of nice to have. But yeah, so AOVs are super cool. Render settings, these are the render settings that I used. The image was 4K, so it's 16 samples, between 16 and 64. Adaptive error threshold is very good to decrease. It gives you a lot cleaner images. And then when you output it, I'm just going to show you, you just do this. A certain place you want to save it to, and then the render name, $f.exr. And then you save the sequence, and it'll, do all of this. This took like 3 to 6 minutes per frame, depending on how hectic things were looking. But yeah, so I showed you that. That was just super quick. But then if you want to composite, you can do some cool compositing stuff. I'll show you that real quickly. So this is the 4K image once it's rendered. So as you can see, it still doesn't look like you'd expect it to look. But then I separate out the emission layer. Right? So because I have AOVs, I can separate this out, which is awesome. Then you just rename it to C from emission. And then I can apply some Redshift post effects stuff on this. You can't just like blur it, right? You don't have to have post effects. I do the same thing with the volume. I separate it over here and post effects on it. And then composite them together. Like I did the compositing in Houdini. You can, that's okay. Another Redshift post effects. And like, you get that. Right, so it ends up pretty decent. AID noise. And then you add grain. So I always add grain. It just gives it more of a filmic look. There's always film grain. Even in like high-end movies, there's always grain. So it just makes an image not look too crisp. Sometimes 3D can look too like sharp. So adding a bit of grain is nice. And then you just output the sequence. And like I have these as post-process files. And then you can composite it in like whatever you want. Premiere Pro, Nuke. Oh, no, wait, not Nuke. Maybe Nuke. Whatever else. DaVinci Resolve, After Effects. The end result, let me go and find it quick. Looks like I can't find it. Why can I never find anything? Okay. I'll show you the Instagram announcement. Right? So this was it. That's how it looks when it's done. And I showed you how to do all of these things. So it's not like there's anything in here that was like hidden from you guys. All of that stuff was in this live stream. Just changing colors, scales, tweaking things until it looked right. And that's like half the fun. Like just changing stuff, playing with the settings. So you can see like in this frame, you can see that there's like really nice color variation, scale variation. The hero particles are made of those tubes so that they look a little bit more full, while those ones are just like basic particles. And yeah, that's it. So I'm probably just going to hang out for a little bit and chat. But yeah, that's it. That's it, guys. That is it. Oh, that was pretty hectic. It's fun though. Um, good after Didi, software scams and Jesus out of me. Thanks, man. I appreciate that. So, yeah, like when I started, for sure, Houdini was scary. It's always scary when you're starting out. Like, it's just because you look at it and there's so much stuff going on. You're like, what is going on, man? What do I do here? Um, how much storage do I have in my PC? Uh, I'm capping out here, man. It's not looking good. So that's a 2 TB, 500 gig. I swear I had more. Oh, anyways, not that much. Like 4 TB maybe total. But then I also have like some Google Drive space, things like that. Yeah, if only there was a series that showed Houdini wasn't scary. Did I learn Houdini somewhere or self-experiment? A lot of self-experiment. So trying stuff out. I find that trying to copy effects is a really good way to learn because you have a sort of end goal in mind, and then you can just try whatever you want. Maybe that's like better if you're a little bit further along in the learning process. Initially, try and learn like the basic stuff, but then start with like basic effects. Like this is a fairly basic effect. Maybe the volume stuff is like a little bit, and the cop stuff is not so amazing. But yeah, like you can work from there. Um, I was awesome, ready to watch it like 5 times to achieve the result. Great stream, man. Thanks so much for this. Looking forward to that Patreon course. Awesome. Thanks, Daniel. Thanks for being here today and on Saturday. It's very nice seeing you guys again. Familiar names. Do you work on any movies? Yeah, some. And some like TV series. But it's kind of I don't know. I don't know if I really enjoy working on movies and series that much. I'll be honest. Maybe I would if it was like a little bit more freeing, but you find that when you're working in the industry, there's like pretty strict. There's not much room for creativity a lot of the time, so it's maybe not as fun as like streaming or making tutorials and stuff. But yeah, like we do occasionally. Are you planning some other live streams this summer? Yes. I don't know what the next one will be though, but I'll probably start brainstorming tomorrow. And yeah, there'll be announcements. Yeah, Instagram. If you're not following us on Instagram, at 9_between. I think that's it. Using C4D. Really want to jump into Houdini? Any tips? Jump right in. Yeah, just give it a try for like give it a try until you're past the super scary phase. So give it like a month. Try Houdini for like a month. And if you're just not clicking with it, then come back later. Like I actually started learning Houdini when I was learning Blender, and I was like, man, the software sucks. And I left for like a couple of months, and I came back, and I was like, wait a second, there's something here. There's a reason why the software is like used in the industry and why it's so big. And so then I learned it a bit better. Also, I learned it smarter. The way you learn actually affects like your perception of it. Quite a big deal. What's one of the more advanced effects that you've worked on? Man, ocean simulation stuff is always a pain. Getting whitewater to behave. There's like there's a running joke. My brother always just like makes fun of me because I can never get my whitewater right. But I mean, I get it right eventually. And especially in like the early days, whitewater was rough. But now I figured it out, especially like whitewater rendering. I know like when I started, I was like, this makes no sense. You take this giant like bunch of particles, convert it to a volume, and it just looks like a mess. It's just like a clump, like a lump sitting on the ocean. What is this? And then slowly I learned the techniques that you use for whitewater and things. But ocean simulation is generally what I do. I've been doing a lot of it recently. So yeah. Oh wait, you're the guy who made Houdini isn't scary. Wait, are you serious or are you joking? I don't know if you're joking. Yeah, I'm the guy who made Houdini isn't scary. Welcome. Ayush, I'm working in DNEG. Oh, nice. Congrats. I know DNEG's pretty big. Like, I don't know. I think the is it DNEG like London or whatever? That's like the really big one. But yeah. Okay, so I'm gonna stay on for like 5-10 minutes. If you guys have any questions, feel free to just drop them there. But the stream is basically done. I'm going to remove the little Loki spoiler thing, unless we want to talk about Loki. Do you guys want to talk about Loki? Seriously, I have it on my watch list. Yeah, yeah, yeah. Give it a watch, man. Like I'm fairly proud of that series. I was actually, it's kind of funny. I was sick when I recorded part 1 and like part 2, and so my voice is really nasally. The first part I'm kind of talking like this, and it's really hard to understand. But then I sort of re-recorded part of part 1, and it was a bit better. And like that's my only regret about that Houdini is it scary series, is that I didn't record it when I wasn't kind of stuffy, because it sounds a little bit off. But yeah, no one's complained about it, so I guess it's fine. I was actually surprised someone made something like that. Timelines branching. Oh yeah, that's true. That was like the big glowy stuff. It looked like veins. Yeah, that one is pretty cool. Branching effects are pretty interesting. Because you can do like cool branching stuff with like particles. Where you just have like a single particle moving, and then you're like, pew, shoot one that way, pew, shoot one that way, and then make those shoot in different directions. And like it's super simple branching, and then you just connect the points up. And then you can do like crazy stuff, like you can do poly wires and then like twist them and make them glow, and then you end up with like probably how I imagine they did the branching thing, probably with some like volumes and that thrown in. But yeah, you could do like branching stuff is fairly simple at its like core. So that's pretty interesting if you want to try it. What do you recommend to learn? Distraction? Oh, destruction. Oh, right. Sorry. What do you recommend to learn destruction or particles? I'm trying to learn effects in Houdini. Not sure if you're asking destruction or particles, but I would say learn particles first. And then move on to like more complicated dynamic stuff. Start with pops. Pops is simple. Pops is nice. You can do like simple effects. You can do like sparks, and you can just do fun stuff with pops, and it's fairly easy. But then it gives you these sort of ideas of how attributes move around and stuff, and then you can start doing the more complicated stuff. Is it true you and your brother learned Houdini at the same time? It's a bit weird because I learned Houdini, but it's not like what he specializes in. So he specializes in modeling and texturing. So we didn't really learn Houdini at the same time. Like I've been in Houdini probably more than him, but he knows other software. Like he knows Substance Painter, ZBrush, like some Maya, and yeah. So it's like he does other stuff. He's like really good at other stuff. So it's kind of like we fill in each other's sort of weaknesses to make a full pipeline, which is pretty cool. Finished the show 2 days ago, and I thought I would try making the effect. Open YouTube today, and you're making it live. It's meant to be, man. It's meant to be. So yeah. Okay, I think I'm off. That was cool. Thank you everyone for showing up. You made it fun. You're all very chilled. It's like I don't even need mods. You guys all super chilled. Haven't worked with Bifrost. Can't actually say like anything really about it. I mean, it looks cool. I don't know. Yeah, but I don't have any thoughts on it. So yeah, thanks guys, and girls, and everything in between. How old were you again? 24. Yeah. Yeah, so I'm gonna open the Discord. I have a couple of stuff that I still need to fix up in there. Make some channels, voice channels, sort of sort out the roles and that, and then I'll open it. Destroyed the Bifrost. Yeah. Thank you for the stream. Yeah, cool, man. Pleasure. It's great. 3D artists are chill, in my opinion. Yeah, I think most artists are kind of chill. I think it's kind of like artists get a little bit like they chilled, and then they kind of lose their mind at some point, and then they're just not chilled. They're just crazy. Artists go off the edge. I think. Gotta be careful. Do you use Arnold? Once or twice. My brother used Arnold. He's more familiar with it. Hi, do you model in Houdini or other DCC or not model at all? Model in Houdini. If it's anything organic, then ZBrush. But like hard surface, anything like that, Houdini, anything organic. Yeah. Deadline is what we call them. Yeah. Okay, guys. I'm out. I'll stay in like text chat for a little bit, but I'm gonna end the stream. So thanks. That was a lot of fun. I hope that I can do this again, and if you guys are interested, then I'll be around. So yeah, if you haven't watched Houdini Isn't Scary, Vex Isn't Scary, all of those things, I think maybe give that a watch. And yeah,